Hello, hello. Welcome back. Okay. Last time we were doing some LSP stuff and parsing issues and stuff. I think I'm gonna leave that stuff a little bit now and work on the actual language a little bit more, because I feel like right now the language is basically, it's not really fully thought out everything. Hello Blue, welcome back. How are you doing? So I think what I want to do is think a little bit more on how the language should work, and I have some new ideas. So basically, well, for expressions, so what I'm thinking is, let's say I don't know, I'll add like a test 3 here. So basically I want to make, well, I still want runic files as functions, and but what I'm thinking is, like, let's say you define a function here. I'll use the proper thing here, even though it's like it shouldn't work, but okay. Now the curly brackets or the curly braces are implying there's a block here, right? But what I'm thinking is that they should probably be optional. And what I mean is, like, if we do this optional and basically, let's say this is just hello world, right? Now this is like an expression, right? So the thing, this is like the function body, right? What comes after the function signature. So first we have function keyword denoting we're making a function. We have the standard in type. We have the name, arguments in parentheses, standard out type, and then we have the function body. And the function body, since in this language it's perfectly possible to have a block be an expression. The expression will simply be ran as, you know, in its own context, and the result will be a process handle as it is right now. So you could have, like, you know, you can have anything in here and it will, you know, it will just work. And then, so B will actually be set to this. So this is actually an expression that creates like a, a process handle. And so B will be set to the result of this. So basically it would have standard out hello, and it would have a declaration C as well on it. What's the progress right now? Can you type? I can't unmute for some reason. I can't unmute. Can you hear me? Anyway, yeah, so as I was saying, like, the blocks are like, they should be just expressions that produces a value that we can get. And since we can't do that, then the function bodies could either be just an expression. Well, it is an expression. It is just an expression. It could be either a string or anything. It could be a function call. it could be a block with stuff in it. So basically the braces are basically, they could be yeah, they could be anywhere. They don't have to be in like a function body. They don't have to be in like an if statement. They are themselves an expression, which should simplify a lot of things when it comes to like expression or, well, parsing. I guess it could simplify, it could also make it worse, because if we assume that we have to have braces surrounding the body of the if, then it becomes pretty easy to kind of see where it is. If we just have an expression, you know, maybe that becomes harder to actually parse though, because this could technically be a function call. Let's say this takes some kind of string, and then you would put this here. Now which so basic, okay, so if, and then the condition, and then we have the then basically here. Hello NG Tantai, welcome back, how's it going? Can you guys hear me or what? Or am I just talking okay, thank you. I assume the one means yes. So there could be ambiguity, but yeah, that's the problem with this approach. Maybe it's like, okay, where does things start, where does things end? But I think in a program like this, maybe the future will be like indentation based, maybe. I don't know actually. Because the thing that the functions are actually, they are kind of like Haskell. Like you provide the name of the function and then a space separated list of arguments, right? But yeah, basically we could change blocks. Any block, like blocks right now are actually, they are already expressions. Like you can parse a block as an expression. You can have a block expression like this. There's nothing wrong with this. This is actually one of the expressions that you can have right now, and it already works. And you can already do this right here. So this is already a thing. It's just that when we parse functions and if statements, we kind of force this block to be here, but we don't really need to. We could just as well parse an expression here. So I think I want to go that route actually, because then we don't really have to have a distinction between a function with a block body or a function with an expression body. It will just be expression, and that's that. And there's no real, there's no, we don't really care if it's block or not, because both are the same basically. Same with if statements. Right now we only allow blocks, but we could just have expressions. I mean, I guess this is common in I just realized this is actually common in programming language, that you can actually omit the thing and only have like a one-liner. But usually you have like a one-line statement. But this is going to be more an expression, like in Zig. You know, you can have this, else, false, or something like this. You know, and that's fine. So, yeah. Yeah, so I think I'm gonna try and move to this type of thing. And also, another thing that it kinda moves towards then is that, let's say we have, so let's say this is like random or test3 rm here. Let's say we have another file called, you know, expression function or something, I don't know. Or yeah, this is kind of denoting that, okay, runic files are functions, but yeah, and if you call them from runic, which I will also think about, like for example, let's say we do run expression function.rn or this, or maybe it will be like autocomplete like this, I don't know yet. Probably like this. It's gonna probably look like this, just like the import, except the import is gonna be like doing something different, perhaps. I'm not sure actually. It could either be import or it could be just run. But basically, this is, I'm saying like explicitly we're trying to run this as a function, right? Now, if you have a block in here, so basically what we could say is that runic functions themselves could just be an expression, like one expression, right? So it could be a block, and that just is a block. It could be a string. See what I'm getting at here? So basically, if you run this runic file, it's just an expression called hello world, and that would be sort of the that would be the result of the function, and the result in runic is basically standard out. So this string would put the standard out. So this would be the hello world of runic. It's just a string with hello world in it. And if you run this file, you would get like hello world to the output. So that's pretty simple for, you know, for a program. Basically everything is stripped out. But that what happens. Also, it's like implicit also like exit 0, of course, like success, because an expression basically like this, an expression like a string can't really fail if it's only, you know, a string literal with no interpolation or anything. But I'm contemplating, because it's gonna look weird if you have to like, you're gonna get like, if you try to put some, you know, echo hello world, echo do something else, you know. Now this is gonna be an error probably, because it's not in a block, so you don't have several statements. So I'm contemplating of having like a special case for files. If you have an expression at the top, like if you only have one expression, we're gonna treat that as we're gonna treat the whole file as like just that one expression. But if you have several statements, now all of a sudden it's a block instead. So we're kind of implying it's a block now, which could be confusing, I guess. You could also you know, force the programmer to put, you know, if you want to have anything, if you want to have more statements, you have to have like a block expression. I'm not sure actually. because it basically makes things very like ultra consistent. But it also like, yeah, it's like the rules doesn't change depending on the context, basically, is what I'm trying to say. It's all gonna be the same. Yeah, I don't know. Maybe we'll start with this, and maybe later we'll add that. Okay, well, if it's if it's the file, we'll make an exception. Like, okay, just like in Zig, actually, Zig does have kind of like an exception as well. Also, there are other exceptions, like you have the top of the file, you know, function definition of the actual file itself as well. Like this is only allowed at the top scope of a file. So there is differences, you know. In Zig also there are differences because the file is not you don't have to it's like implied that a file is a struct, right? So you don't have to like surround it in a struct statement. It's already implied it's a struct statement, right? So yeah, so it could be like it's already implied it's a block expression or a function, you know, but the thing is there, like, it's kind of like we have to, it's like context dependent if it's a block or not. We don't know if it's a block or not until we read the number of statements, basically. We're trying to read several statements. If it's just one statement, it's an expression, one expression. Otherwise, it's a block. Hello, Zormelot. Welcome. Yeah, so I don't know. I just know right now that the blocks are definitely an expression, and they can be stored in value or in identifiers. They could be used later. You can echo the contents. You can you know, get like it's like executing a process, basically. It can fail. Then you get like exit code. You know, if the type could kind of be also implied, because the block execution type will basically, like right now it's a process handle, but we don't make any distinction about, like, standard in, standard out is always a string. You can always get an error potentially, but when you're in Runic land, that's gonna change. So then we can infer, okay, well, this one infers that it's just a normal executable, basically, because yeah, this infers that the error could be a byte, and it also implies that standard out is a string, although it doesn't take any standard in. So I guess standard in would be like void here, and then it gets executed and put into this variable, and then we can use the standard out, standard error, or whatever, everything there. Yeah. Okay, so well, this is probably gonna be a pretty simple change here. I'll just remove this here for now, and this one. Okay, so this part we should actually be able to do these things. And maybe this will work. We'll see. I will go to... Well, first we can... No. Actually... I want to go to... Where do we go? The parser, perhaps? Yeah, the parser. So we should have like parse function. Hello Panelverse. Yes. How did you how can you tell? Now I had other people coming on here to tell me that they can hear it too. That I'm Swedish. Okay, so here we are implying we are parsing a block, but actually we could just parse an expression. Oops. There we go. And then the body would be, well, let's just make this, I think it's called expression. Yeah. Let's just do that, or yeah, that's the body for now. And we'll change the type later. And the body span is, or the end span is that. All right. So now functions could potentially be parsed as, you know, expressions. So, but if statements doesn't have that, so we need to change that as well. So parse if. Here we have the if, condition, capture, and then we have the then block. Instead of a block, we'll do then expression. What is the tech stack you are using? Well, the operating system, like I'm running on WSL. Or are you talking about the program language? Or okay, so I'm using like Ubuntu on Windows with WSL, and then this the editor is NeoVim, and then the language that I'm using here is called Zig. To build the language, I'm using Zig. Else, no, what's good? Then expression, there we go. That's the span and okay, we can change this here a little bit. So this would be span and then end at. I will rename you to end span. Or not. And you would be just the span itself. All right. Expected. Oh yeah. There we go. Right, so now we don't have a block anymore, we actually have an expression. There we go. And then the else, we don't really need to, well, okay, yeah, we do need to change this expression. Actually. And then this, we actually need to change. Hang on, the if expression span is okay, that's set. So this would be like if we have an expression, then it's expression.span. Otherwise we have an if expression, and that's just .span. Here we go. and then U should be now an expression here. And U need to be a course expression. There we go. Right. Okay, now it does change a little bit. Well, I guess it doesn't really change. Like if you parse a block, it's gonna be the same thing. So, and then if you parse an expression, it's also gonna be basically the same thing. Let's see, block name, block in populate. Oh, I see. So this is actually just an expression, and then we do we just append this expression. There we go. There we go. All right. No field name and look. Language server could not rename. VS Code is much more efficient. Yeah, it's the language server. It's the language server for some reason couldn't do it. Usually you can do it. Like I don't know why it couldn't do it this time, but you know. I don't think VS Code has its own language server for Zig, although I'm not sure, but I'm using ZLS. But then I think there may be other language servers as well. I think there's at least 2 from what I've seen, but I've been using the same one, basically, ZLS. Okay, so we don't run block, we run expression. And you don't need to be that. And same thing here, we get an expression. Which we just run the expression. Now instead, there we go. No field name, then block instruct. Yeah, so this would be wrong expression, or wait, where am I? Evaluator. Evaluate expression. Although here we actually need, like, if we have captures, we also need to like create a context and all that. So I will add that here, handle captures, but right now we don't really have any captures, so it's just gonna run in the scope directly. And this is the print thing. Okay, so you render expression. Okay. No more errors. Replacing test finder replace so much faster. I mean, I think if you have a good renaming feature, I think it's nice to actually get it into your. I mean, yeah, I think it works. If it works, it works really well. I think it's a nice feature. I don't think it's a bad feature. Like search and replace works also, but then it's a little bit more risky. And of course, it's good to learn how to do that as well. Of course, I'm using both, depending on what I need to do. But yeah. So okay, so let's go test 3, and we should be able to parse this now. I think. No? What about the tokens? We should be getting tokens, yes. Okay, so what is happening here? Unexpected token. Alright. Right, so we're parsing a function. Oh, I see. It's the beginning, it's a standard in type. Right. I haven't done the standard in types yet, so I have to remove this. Maybe I should have like a maybe type there. Just to get it in there now. Parser. So we'll do maybe type before the identifier, and this is the standard in type, and then we don't really do anything with that, but I will put that here anyway. All right, there we go. No, wait, that's the tokens. That's also the tokens. Where's the AST? Okay, still no AST. Okay, so now we get here, and I guess it fails. Okay, apparently we fail now when we don't have arguments. What? Also, parse param. Yeah, I recently added this. This doesn't have a breadcrumb, so I need to add it. Oops. There we go. Now we should see like parse param. So it's trying to parse a parameter, and yeah, it fails. I guess what we could do, perhaps, hang on, the parse list should have like an ending terminator. There's like a delimiter, but then we should also have like terminators or something like that. I'll just add whatever. Let's just make it into a list here. If you want to have several, potentially. It could also be a function, but or both. You know, you can use an enum, union enum to have both options available. But let's just do that. So I think what we do then is we look at open. Well, open is not really a great name though. Let's call this start, and then I will if start tag is, well, okay, we have to like do, is there like contains terminators expected count 1 and start. So if that is in the terminators, we can just return span is kind of weird now because there's like nothing in there. I guess it could be sure, let's just take start span. Why not? Let's just take the next token there. All right. So now you can have terminators, and you are gonna be the right parentheses. Why is it like this? Okay, let's do const. Maybe that fixes it potentially. Oh, I see. Start tag. There we go. Okay. So it got past the thing, but then we're struggling over here. I think. Yeah, I think it's trying to parse a pipeline here. So we got, which is correct. We got the hello and the string, but then we reach an else, which should be like a terminator for an expression, basically. So is expression terminator. We should have else here, which we don't. There we go. Okay, and then we're trying to read something. Oh yeah, null doesn't exist yet, so let's do false or something. Actually, let's do this so it's the same type. There we go. Now we get an AST. Can we also run it? No. Member object type undefined. Oh, so B. Okay, so we cannot resolve the type of B, so we cannot determine this member access here. Okay, that's fair. Yeah, because blocks, I haven't implemented types for them yet, like type resolution for them, I think. So should we try that now? This, I'm pretty sure this comes from the error checker, yeah, or the type checker, I mean. I guess we could try and like disable the type checker for now, because I think it's just unnecessary kind of overhead right now, perhaps. I would just like to run the thing without checking the types. So I will add an option for that somewhere. Actually, we have like, where do we get parse command line? Skip type check. No. Okay, so great. Do we have this anywhere else? Yes. Cool. Right, now we need to incorporate it into the run script. Wanna try Zig one day? Do it! It's amazing. I've only ever used the compiler to compile C code. Oh, well, there you go. You're already in the machinery. That's really cool, by the way. I mean, yeah, it's actually amazing that we can have that now. I'm not doing it myself, but to the extent I've imported Raylib, which is a C library, I believe, not C++. I think it's C. Yeah, into my other project, and yeah, they even have a Zig config in their repo, even though it's a C project. So it just goes to show that Zig is gonna infest everything, basically. And then everyone has been assimilated. Right, so let's see, where do we have like type check only? Right, now this is only used here, so we can basically have a giant if statement here. Where is the options at? Config, skip type check. If we don't skip it, we run it. Okay. So now this fails, but we can add skip type check, and there we go. It's running. Ah, you ported some older libraries over to use Zig build system from CMake. Awesome. Whoops. Okay, so what's happening here? We create this and we echo it out. We also have a function that's only like an expression here that we hello out. And what is this actually? Like, what is in X? Let's echo X. I think it's just gonna be like a string. And also like these parameters, since this function doesn't have arguments, and also we don't have argument passing right now working for functions either, they are not gonna do anything. I think this is just gonna be hello world. This prints out this hello, that's from there. No, it doesn't print hello. Okay, so this doesn't do anything. It doesn't print it out because it's not. Okay, well, this is the type expression, right? This is the right. So because we don't have like return values, basically all the values like inside this expression are basically deinitialized right now. But how it's gonna work is basically if you have an expression like this, I want to add like when a function gets called and its expression is something else than a block, or it could be a block as well, I guess, then that expression is going to be the output of the functions. That's going to be put out into standard out, basically. So you have to match this with this now, basically. So you have to do, it has to be like this. And then when you call hello, it's basically going to be like calling a process. X is going to be, you know, you could put standard out, or you can just coerce it into standard out like this as well. But if we remove all this crap and we look at this, we see that this should print hello. Yes. Hello world. It all works. Now, I'm not sure if we can access C here. I don't think so. Because this, the result of B is like a process handle, and you can only access standard out, standarder, and yeah, that's it actually. We can't actually do anything else. If we just do B, it's gonna coerce into standard out. Yeah, so that's you know, a little bit of how this language is gonna work. Yeah, like execution results are gonna be, you know, a kind of part of this, of the standard. I'm not sure actually if it's gonna be like a struct at the end, in the end, if we're just gonna support it as a, because right now it's like a built-in type in the language, but it could just as well be just a struct that's defined in, you know, when we get structs and we can define that, that should probably be what's gonna happen there. And I guess we'll also support like string coercion with some kind of implementation function that you can add to anything. And yeah, and I don't know there if we're gonna use just, you know, a function on the struct, or if we're gonna have, you know, traits, or if we're gonna have like type classes or interfaces, or I don't know what's gonna happen there, but basically it's gonna happen in some fashion or other. I think I'm not gonna go with type classes because it feels very daunting. It would be really cool if we could have it in a scripting language, but yeah. Anyway, this part here, yeah. So the idea here is that you call this function, the result will be kind of, it will be a process handle right now. However, it will probably just be this string here that denotes the standard output of this function. And then if you can have an error, it's gonna be something like this, some kind of error set like this. If it's an optional, you can have this, and so on. But also it's kind of implied that the strings are, right now at least, it's kind of implied that it's streamed as well, because you can potentially just call, you know, tail something like this, and that will actually be the output of hello. Now actually, since we're calling tail here, which is a process thing which will put things out to standard out, now we should actually see that or not actually. I think, okay, yeah, I think it's because it's stopping here. It's stopping at this point. But if we just say echo hello, now it should print it out. Yeah. So so also it's kind of implied that this is like a stream. So I am kind of contemplating if we should like have that part of the type. So basically, because before I've been thinking like, well, an executable is basically a function that maybe takes a string input and, you know, the name here, and then it takes a variadic number of string type arguments, right? And the output is also like, you know, you could get a string or nothing. I guess it could be an empty string as well. You could, that depends on how you see it. But and also the exit code is some kind of byte value. So this is kind of this is going to be the signature of the function, or of executables. However, now I'm kind of leaning towards this being like a stream of strings or stream of bytes instead of like just a string, because a string is essentially well, now we don't really have that, but if I say like S is a string, now S, you can see this is actually an array of bytes right now in the underlying system here. But I'm thinking that this should actually be like a stream of strings or a stream of bytes. Works too. And same thing with the output. Like stream of bytes is like you get 1 byte at a time. Stream of strings, you could potentially get like a chunk at a time. So stream of bytes is, I guess it's more, I don't know. We'll see. But basically going in this direction instead. So this will probably be the signature then. So once we can like support all of this, we can basically just turn all executables into these kind of functions and then have them just integrated in the system. Also, what I would like to have is when you only have like an expression here, because now it's like it's gonna be empty if we ignore this part. Yeah, it's empty because it doesn't actually, like this value, this expression doesn't output anything to stand it out. But what I'm thinking is we should have like a string coercion, or we should have like the expression of the function call should be the value of the function, right? And it should be, if it's not well, it should be forwarded to the standard out context here. So if it's not a block, it should get, well, or maybe, well, all expressions may be actually put into, like if you have just an expression here, hello world, that should also be just put out into standard out, actually. Yeah. So once we have this, then that should just solve itself. Will strings coerce into streams? Good question. I I mean, yeah, they would probably have to be, because I'm planning also to be able to do this, like pipe into cat, for example. So now we're piping this into cat. So this, you know, when you pipe, you have to have, well, basically you're gonna have a stream of something, right? So we're coercing this into a stream, but basically this is the only thing that you can put in there. And also you could probably coerce a stream of strings into a stream of bytes. So if this is, but I'm still not sure. I think probably we're gonna say that the functions are actually gonna be streams of strings, because that, I think that makes it way easier to work with. Yeah, something like this. Because then, yeah, we can coerce this into a stream of string. It's just going to be, you know, a stream that outputs one string and then it's done. And this one will just receive that and into standard in, and then we're done. Okay, let's see if we can make this happen here. So basically, you have an expression. The expression itself, the value is going to be trying to be coerced into a string, or actually it could be coerced into a stream of strings directly. And whenever you have a stream of strings in the context here, it should just be outputted to standard out or something like this. All right, let's have a think about that. I'm gonna BRB 1 second here. String already converts into byte array, right? Well, it's really the same thing. String is just an alias for a byte array. Like this is a... Okay, this should be a string. No. What happened to the LSP? Okay, but anyway, it should be a string anyway. There we go. Right. Yeah. It's a string. It should be able to deduce that this should be a string, but okay. Apparently not. Arrays to streams. Yeah, we gotta figure it out, I think. So yeah, because what you could also think about is like, what is a function? And is actually streams, are they also like functions actually? Because really, the function is kind of like this function here. We're taking an input of string. Like really what we're doing is we're basically just supplying a bunch of arguments, and then we're connecting potentially a stream as well as input, and we're getting a string of output and potentially an error along the way. So really it's like I don't know, it is kind of just, the whole thing is like a stream that takes input and out and gives output, and then the only thing that makes it basically into a function is that, well, it's the function body as well, I guess. But once you have the result, you call the well, okay, I guess, well, inside a function you can, like, let's say you have this stream of string, my echo I mean, of course, you know, it has a function body, and we just well, this is just gonna be the arguments, but I'm not sure how to actually define this now. Maybe like this, Java or TypeScript style, not sure, because variadic functions doesn't exist in Zig. So unless it's a C function, that's the only way you can have a variadic function in Zig. So there's no variadic, well, there is kind of like a variadic syntax, but only for defining an external function. There's no syntax for actually getting like arguments out. But here's no problem. Here we can just make one variadic function call, and we can say yeah, we'll just loop through the arguments, and we'll just provide them like this. So this basically, this turns into a list of expressions, Okay, well, you can just do this then. So you would coerce the list of strings into a stream of strings, which will then just be output. It could also, like, it depends on how you want the array to be. Like, you might want it to be comma separated, you know, you might want it to be JSON formatted or whatever, but then you could basically just say to JSON or something like that. I don't know, have some kind of to JSON function that will do that. But if you just do this, you will probably get like a new line separated printing of it, or just simply all of the strings concatenated into one stream without any delimiters at all. And if you do this, it will be the same thing. But I guess you could also do that as well. And that will put the new line in there. You're watching it from broken PC that doesn't even have hard drive. And you're live in Antix Linux USB. Interesting. So it's okay, so it's using like the USB storage. That must be, is that slow? Or maybe it's fast nowadays. It feels like that should have been like a slow process. Moving a bunch of data on the USB. Also, those USBs probably have less lifetime than a hard drive. If you're constantly using it. Okay, yeah, okay. I'm trying to find a logic, path in this here. So basically, any expression is gonna try to turn any expression here into. The problem though will be expressions such as this. Like, let's say you have this hello world, and then you have another one, or maybe this is like a var, like a mutable, and then you're saying s is equal to hello s, you know, some kind of recursive joke here. But this in itself is actually an expression. And you probably don't want this assignment expression to be put out as a standard out. I mean, we could change it so it's not an expression. We can actually make it into a statement. So then it makes sense to have statements and expressions separated. However, it's also nice sometimes to have this as an expression. But yeah, I guess it's not really a super usual thing to have. My PC is with me right now, so I allowed a old laptop with 5.6 RAM. 5.6. What? Antics Linux is light. Okay. Well, what I meant was like, if you don't have a hard drive, you're gonna be using, I guess, the USB storage, the USB as storage. That's what I was saying. Because when you're watching here, you're downloading a bunch of stuff that like makes changes to the USB like constantly. Okay, maybe man, this is a little bit annoying here. I have to think about this. It would be cool if we could make just expressions be, you know, put out there, but or maybe we just don't allow this to be an expression. We could encounter other things to also be like, you know, if statements are also expressions. So basically you have an if true, and let's say we echo this is true, else echo this is false, right? Now this echo here, this is going to be put into the context of this if here. So this if is supposed, this should capture whatever thing is going on in here, and this else is capturing this thing over here. But then the result of this entire thing is either going to be this or this, and then we're taking that into the outer context. Yeah, that makes sense. This shouldn't be a problem here. I'm just trying to think like, what situations could we end up in which could be potentially bad with this one? I guess we'll find out. We could just make this happen here, I guess. Like right now, we could just coerce this into basically a process handle would be the equivalent right now. Yeah, so now it's saying this is true, but if we implement this thing, it should be saying hello world, and then we'll change this to not output anything. Okay, so we have to go to the script runner, evaluator. So we have a thing called run statement, which will run the statement, execute the statement, execute the statement. Not sure why we have two of these. They are basically not, there's no difference between them, but this is how the scaffolding from the AI did it, so I just haven't changed it. And then we have like, so we have like distinctions between statements and expressions. Not my decision either, but we have like binding and function declarations. Those are the only things we have. We also have type bindings, but we don't do anything with that in runtime, of course. That's only comp time. And then we have the expressions there as well. So what I'm thinking is that we're executing an expression, which means we should also take the we get like a value out of the expression, which is then returned over yonder. This doesn't produce a value, so the value is actually put out, and then it's actually grabbed in the executor, which is a separate unit here, component in the whole machinery. And I couldn't tell you really what the difference is, but basically we take the value out, and we also check if there's an error here. But we take the value out, we check if we get the value, then we also deinitialize the value. But we also, well, we don't do this anymore. We get the exit code from the value if it has one. If we get an exit code, that means that we have actually got like an error exit code. And here we are checking for success, but it's just for safety. And then here, basically we just render the error, and then we're done. We exit the whole program. Yeah, and then we deinitialize the thing. So so here, when we get this value, we should forward it to output now, if we can. So basically we want to do this. You can see a forward handle output. However, this only relies on like actually, you know what, it's not supposed to happen in here. Actually, it's supposed to happen further in the evaluator, to be honest, because this is only the outermost context. We could potentially have context in further in. So to give you an example here, we have a lot of different expressions here. Now, for example, if you call a function, where we have that, or yeah, a pipeline is a thing, or if we execute a block, that also works. We execute a block, we're running the block in its own context, so we're pushing a frame, which is like a declaration, you know, it's a scope that that the block has on its own, but then it also inherits the parents as well. And then we run the bunch of statements in there. Now, if any of these statements produce output, like to standard out, we take that and forward it based on the current context of what's happening. Now, here we actually don't have a separate context, but if we have a pipeline, or sorry, if we have, wait, no, we have to go back. If we have a binding, which means that basically you have, where is that? You have this. You have something that binds with equals to something else. So the context of what's happening in here is actually forwarded to this variable value and not to the outermost context. Because if you echo here, for example, we echo this, or printf, or echo, yeah, we echo this. This won't get echoed to standard out. This will get echoed into S, and then you can use S as a string, basically, and among other things. But basically, this is how it's used. Like in certain expressions, you have a separate kind of context where all the output is put into some other context, which in this case is this variable S. So all the output is captured into S, right? So so when we execute this binding, what we do is we push this frame forwarding, or a forwarding frame, which has their own standard out and standard error receivers, basically. So these are writers that the context will, or when you evaluate an expression inside this context, it will now forward all standard out and standard error to these writers instead. So that's how that works. Now, which will prevent it to be, you know, to the actual standard out standard error. But if you're in the outermost context, it will actually get put to the normal standard out standard error of the whole process. And now, let's say we get all the way out here, and we get the expression. Now, normally here we get a value out, right? If the value is a function, we actually execute it, because that's how it works right now. Otherwise, we just get the value. So either we get like the execution of a function or a value, but either way we're getting some kind of value out. So what we need to do is we need to take this value, try to coerce it into a string or a stream of strings, and then process it, forward it to standard out. Okay. Also, like if a function, I just realized this, if this doesn't work recursively, if a function returns the result of another function, this is not going to work. I'll just try that real quick actually, because this will, wait, run function get value. Yeah, this just gives us the process handle. Oh, because we don't get like a, okay, we're never getting a function out of it, right? That's the thing. Okay, fine. Anyway, so let's see. What did we want to? No, wait. Yeah, so we get this value out. Here. Now I think here we could actually, this is called execute, so why not put it here, I guess. We get the value out. Okay, and now we're gonna try to coerce it into a string and stream it out. So let's do that. Forward, or yeah, because we don't really have a stream type. That's the thing. We don't really have a stream type, but I guess we could do that. So values as stream, and we can do that. This is a stream of some kind, and then we, I guess it's gonna be like a string stream. I don't really know. I don't really know how to think about this for now. But let's say we have a string stream, and this will produce, this will be like from value v, right? And then we will say forward string stream value as string. We could even have, you know, if we have a coercion from any value to string, we could also possibly just forward the thing directly, I guess. But let's try and make this happen here, and then we'll also return v as well. All right, let's just make this as we go here. So we have some kind of type that we want to stream out. So return a type. This will be a struct. Now I'm thinking the stream could be different things, but for now we're just gonna have a buffer, which is gonna be a list of t's. We can make that constant, doesn't matter that much. And then we're gonna have, let's just do this most simple thing first. We're just gonna have like a use as an index right now. Let's also make it optional, because in I will initialize it to 0. So basically, in like, it's kind of like an iterator. We're taking the buffer, we have an index, and we get the next. Yeah, it's actually exactly like an iterator, to be honest. USB only stores ISO file, entire system lives on RAM right now. Oh, it's RAM. Oh, okay. I worked 3 hours to get this done. Oh, well, congratulations. That's funny. I actually saw a video on YouTube that was recommended to me this morning that said like, hey, here's how to install Linux from scratch, like no distro, just compiling the thing and putting it on a machine from scratch. And it was like 3.5 hours long, and I was like, hey, that would be kind of cool. So I started doing that, but then it's like, yeah, no, I'm not gonna do that. Hello, Flawless, welcome. Hey, what's your thought on Helix editor? I have no thoughts, because I don't know. I think I've heard of it, but I have no idea what it is. Would you ever use it for coding zig? I'm planning on switching soon. Personally, I have time over Unix. Fizzle off. Value time over Unix. I don't know. What would you say would be the benefit of changing to it? So let's see. Next, and then we should get like a nullable t. This would be this. Right. So basically, first we check if index is null, then we return null. Actually, what you could do is you say const index equals self index, or else return null, because now this is actually the actual index, and then we don't have to check for you know, unwrapping this every corner of the program. And then we are going to defer in self index plus equal to 1, which should be a proper operation. I wonder if they ever gonna do something like this, like if you can increase it now. Okay, so unused local constant. Yeah, I guess this doesn't really make any sense right now, because, you know, in this branch of execution we actually know it's, you know, it's a number. But anyway, yeah, I'm getting distracted by these errors, and I know that I've said that, yeah, I've actually disabled the kind of inline errors that you get from these things, because they are distracting. But then I constantly press like the error find button, so, and then it distracts me. I shouldn't do that. Anyway, okay, so we increase index by 1 at the end, and we return self buffer index, except we also need to check if we are at the end. So basically, before all this, we need to check if index is less than the length. Then we can go ahead and do this. If it's more than or equal to length, we should actually just set index to null and then return null. So that's the end. Otherwise, we return the index, but also increase index there. Okay. So that's gonna be the basic like next function. This is a basic stream that just takes a string and then does that. Okay. Next up is we're gonna have a function that is gonna be from value, and this is gonna take some kind of value here, and then we will produce a, I guess this could be like a maybe stream, because yeah, because we don't really know if we can get a stream here or not. So actually, but then we can't use this dot from actually. Let's get a maybe stream, and then also we could have like an error state. I think usually for streams you either have like it's either completed, or you could have an error. That's a usual like kind of pattern that you have with streams. But yeah, and so we could have some kind of error here, which will be a stream error, and we'll create this type here. So let's say we have like invalid source or something like that. So if we got this value and we couldn't coerce it, let's say, we should create a stream that's only this error here, or it has this error basically. And then if we try to call next, we should also check if we have an error, Actually, let's make this optional, of course, so that it's yeah, so that we can check it. So if we have an error, we can actually return that. So we'll just return the error at this point. There we go. So when you try to call next, and if there's like an error, we just return the error, and that will be the result of the function. Okay, so now let's see from value stream t. So basically what we could do a very, very simple check, I guess. What I was thinking here is basically I want to have another kind of component that or thing that will try to coerce something into something else. So basically we would try to do that. So basically let's have like return transformer transform value into t, and that would be the thing. So this would be the transformed, and then or transform into t value. Okay, then we will say we will catch an error. So if there's any error at all, we will just say we will just return. Also, I'll do this, or we could do actually we can do this. Init failed. We get a string t with some kind of string error. We return error is error. Okay. So now we can say init failed, and the error is going to be error invalid source. Otherwise, we will return init buffer we could probably also use like, you know, some kind of built-in thing for this, but I think we need to we probably it's good to have us our own struct against around this. But you know, you could use the like the built-in like reader and writer interfaces as well. Helix is basically a better version of NeoVim. Okay. Cool features like highlight first approach. Interesting. Well, how is it better? It's also for low level, but just built in stuff like tree sitter, LSP themes, surround integration, and also just easier to maintain because no plugins needed. Personally moving away from NeoVim just because amount of time spent maintaining my config just for something barely usable compared to Helix. Oh, okay, I see. I mean, all that sounds very good, to be honest. Like, but okay, but does it have Vim? Like, does it have support for all the Vim stuff? Like, or like, how does it work? Because I can't live without that. Init buffer, init with buffer or something. We'll just take it over now. it just takes it over. And then I guess now let's just say that the lifetime of this has to be handled properly by the user of this, so I won't really do anything with the allocation or anything like that. Actually, well, I might actually, because here, no, because this is just going to be one. No, but we still have like one thing. I guess we could have something like a source that we read from. Yeah, I mean, okay. I guess this could be the reader, actually. But it still could be different implementations, though. Yeah, the pointer has to live somewhere. But actually, if you have a fixed reader, we just don't. Yeah, we don't have any data. I don't think the standard reader fixed. I don't think this actually has. Yeah, it just constructs a reader straight up with the buffer there. So this is kind of built into the interface. Yeah, let's just have a reader, which is a pointer to standard. Well, is it a pointer? Yeah, I think it has to be a pointer, right? Oh man, god damn it. It has to be a pointer because it has to be able to grab, like, find its implementation. It has all Vim stuff like telescope built in, fastest editor I never used because of it being coded in Rust instead of Lua. Okay, so what is the, how do you write the config and stuff? Ridergate. NeoVim is not written in Lua. No, it's not. It's I don't know what language it is. Probably like C++ or something. Like Vim is C++, right? Or C. I don't know what NeoVim actually built in. It's the config system. It's the configs that are in Lua. What are the configs in? So the configs in Helix is Rust? So do you have to like compile them or something, or how does it work? C, okay, yeah. I'm really thinking about how this is supposed to work here. Like, we could also have a very simple thing. You could have a reader and a writer. However, reader and writers doesn't work here actually, because T, it doesn't support any type. It only supports strings, I'm pretty sure. Yeah, okay, so that doesn't even work. I think what we'll do is we'll make this into like a union enum actually, and then this would just be the buffered string. So we'll have like the source, it's gonna be buffered, then it's a buffered string, and we'll put this over here. And then you will be buffered. I'll just add this convenience function here. Convenience function. I guess the error can actually be here. Yeah, the error is but then how would you set it when we get an error though? I mean, we could get the parent. We could get like parent is field parent pointer of we could also say if stream t dot has error self or get error, then we return it. We could do something like this, and then that would work like this. So you have function get error, and then you would have the pointer, which would be a pointer to one of these. But this is wrapped in a union enum though. Okay, whatever. Let's just put it in here, I guess. Let's just put it in here. Whatever. I was trying to make it more generic. I'll put the error in the, because yeah, whatever. Yeah. All right. So then we also have the next function here, which would be self this return rt, and we just return. Also, it could be a stream error. Return switch self. Oops. Inline else with a star next. All right. So we're just putting that forward. Oops. There are no configs for binds, themes, and stuff, but are in total very minimal. What are your long-term plans for Runic? I mean, it is kind of like it is a pet project, but it would be cool if it could grow into something. Like we will see, you know. And like right now, I'm just treating it as a pet project and just having fun creating it. and learning about, you know, making languages. Well, it's kind of funny because when I switched to NeoVim, I switched from VS Code, where VS Code was kind of that philosophy where, you know, it was just easy to install everything. Everything was built in, or, you know, then the manager, plugin manager, and everything, extension manager, and you could find probably whatever you needed. And I used like Vim, the Vim extension to get like some Vim functionality in there and stuff. But then it's like, yeah, but I wanted to go back to NeoVim because then I could. I mean, what do you say? If you want to make your own configs, that's a lot easier than in like if you want to make your own custom things. Then that is like, it's more easy to get started and just go ahead and do that if you want to make something custom. So I basically went from that philosophy of just having everything done for me to doing a lot of stuff myself. And I don't use like a build, like, you know, one of those downloaded the configs or whatever. I just did everything from scratch, and I want to keep the installation very lean, so I only have plugins that I deem are super necessary, and then try to go back to like learning, like, you know, Vim basics to be able to utilize, you know, the editor better for what it is. Which, you know, arguably I've not done a super great job. I've been like, I don't actively go and try to learn new stuff all the time, but I, you know, sometimes I learn a thing here or there and try to incorporate it into my current like workflow. But I've used like Vim on and off for a long time, and this is the first time I switched to NeoVim, and I've never switched to anything else after that. Will you write your own compiler for this language? No, probably not. Like, that's not the goal of the language. The goal is that the language is going to be a scripting language, and it's interpreted. So it's probably not going to be compiled, because the purpose of the language is not to get like some optimized code to run something. It's not the purpose is not for it to be like fast. The purpose is just to do some kind of quick and dirty script that will solve some issue for you quickly. That's the purpose. It's, you know, it's like Bash, a Bash like scripting language. So it's not supposed to be like, you know, fast or anything. It's supposed to be productive. Creating a language using other language would be easier, but compiling, getting that output will be harder. Also, I won't usually for programming language you will create, well, I guess the mostly for compiled programming language is that you would recreate the language in the language that you built it in, but that's not going to happen here because it's like an interpreted language. It doesn't really make sense. I don't think it will be super good because it's not going to be that fast. But Zig is perfect. Zig works really well. Yeah, so basically I just decided one day that, hey, now, because I went a long time thinking that, okay, well, I should move to Vim or NeoVim, but I just wanted to work right. And the reason I chose the NeoVim over Vim, of course, is because well, it's easier to configure it with Lua than Vim script, and it has like, you know, I guess more support for you know, LSP and all that stuff. Like I remember in Vim where I used like a plugin called ALE or ALE, but it worked, but it also felt very, I don't know, archaic for some reason. F#, C#, Java. Yes, but that's what I mean. Those are like compiled languages, and they actually compile like, yeah, for scripting languages it doesn't make sense. So basically, well, once I knew I was want to switch to Vim or NeoVim, so I switched to NeoVim, and I went through all the, you know, like lists of, like, you know, you have these lists of great plugins and stuff. I think they're like an awesome list or whatever it's called. So I went through all that. I looked at, okay, well, what makes sense for me? What do I need? What just the philosophy of keeping it lean, and I just went through everything, and then I just added the things that I thought make sense, and then I did a little bit of my own, you know, config, you know, from what I wanted to have, and then I was done. And I basically just here and there went back to the config to add a little thing here and there, but I since then I've not spent basically any time on the config. It's just if I wanted to tweak a little thing here and there, or, you know, for this runic language, which I added like tree-sitter highlighting for, but it's not like you have to go back and maintain it or anything. So it's like once it's done, it's sort of done. And then the upside is also now you can tweak whatever you want. That's the upside. Like that's a bonus. Like it's not something that is not good. That's just the potential of what you can do. You can potentially improve it to whatever you want, and that's what I want. I want to have total control, and I want to be able to, hey, I wish I had this. Okay, but then I can just make it, and now I have it, and that's that. Just like this language. All right. Anyway, let's see if we can make this work here now. So, well, okay. Of course, string doesn't exist in. It's like this. All right. We don't have the transformer. So let's say we have transformer, can transform anything to anything else. Super magical. Maybe I should start with just a string, because this is like so. But okay, well, what you can do is you can just make, like, let's make this transformer here, right? And then we have a function called transform, and it takes a type and a value that is like of any kind. Highly templated, this function here. And then we will return t, maybe, or an error. I guess transform error. I guess no, let's just make it nullable, I guess. So let's do or else. Yeah. And then the only thing we're gonna support right now are strings. So we're gonna say if t is not equal to a string, oops, JavaScript, then we're gonna do a compile error saying type name t is an unsupported transformer type. Okay. And then the type of value is going to be a value. Actually, this is going to be value, actually. Yeah. It doesn't make sense to have anything, basically. Right now, at least. Well, we're going to have transform value. So basically, now we can... Yeah, now we can switch on value. And basically, yeah. So if we have a string, which we should have somehow, I think, yeah, we have a string, then we can just say, first we'll get, well, this is a ref, so we have to get the string out, and this could be an error. So if this is an error, we will just return null here, because the ref could be like deinitialized or something. Actually, probably, no, it's not initialized until the outers. No, because this should be a value that we should have, yeah. So, okay, what do you mean by highlight first? What does that even mean? Yeah, I mean, I don't mind spending like a day or even a week on building like a nice config, and then I don't have to basically touch it ever again, basically. Just for, you know, if you want to build something, again, that is the upside. Like, yes, there is a cost at getting started, but then you get the upside of actually being able to modify and customize anything you want. Anyway, string, yes, so we have a string, then we can simply return the string. There we go. And should we dupe it? Is it dupable? Doopy doopy doop. I guess we'll have to dupe it because other things could get turned into strings as well, and they should be duped as well, probably. Maybe. Well, let's forget about it for now. Right. So let's say we have this transform now. We can do return, and we'll do like init single transformed. Which is just a T. And then it's not going to be buffered, it's going to be something else now. So it's going to be a single stream. And we'll copy this. Single stream. And we're not going to have the thing, we're going to have the T. And we're going to have an error, or consumed is a bool set to false. And this will give us this, which is value, is T. And this would be single, and this would be value. Alright, then you have the wrong type here. So we just call you this. And we'll remove all. Well, okay. Buffer is buffer. There we go. I guess it makes more sense to put the error here. But it's all, oh yeah, wait. I'm stupid. I'll just put the error over here. And then in this next function, I will check if error. There we go. Okay. Problem solved. We don't have errors here. We don't check. There we go. Okay, and then for this one, we're simply gonna check if self-consumed, return null, otherwise consumed is true, return value. There we go. All right, and this will just be source undefined. All right. Okay. When you press V in Linux, it automatically does it for you for every word and character. What? Also, multi-line select like VS Code when you do Control D, where naming you have to do a lot of regex for that. What I mean, multi-line like this. I mean, it's not. It's like the multi-line in Vim is not perfect, but there is multi-line. Okay, multi-cursor. I don't actually know if there is multi-cursor. You can multi-line, yes. Yeah, multi-cursor. But I you know, multi-cursor. I always thought it was really. I don't know. To me, it just feels like I never used that. Multi-cursor is just like, well, instead of multi-cursor, you could just do I try to be better at making macros, for example. If you want to do a bunch of changes to a bunch of lines at the same time, or usually the thing you want to do is like rename a thing that you just use LSP, or just search and replace in like in this string integer, you know, something like this. I don't know. There are things you can do. Of course, it's, you know, if you're really like, I don't know. When you have like multi-cursor, I always thought it was time consuming to just click there, and then try to do something. I don't know. I try to get better at using like only keyboard things as well. Like I switch between mouse and keyboard depending on what I want to do. Because sometimes it's easier to use the scroll. Oftentimes I use like mouse scroll to scroll up and down. But then I also, you know, of course, use search and you know, page up, page down. It really depends. Maybe it just depends on where my hand is at the moment or something. I don't really know. But also, like, I notice like when I have my hands on the keyboard all the time, I have these ticks that I go like up and down and :WA and tree-seater objects for selecting. Yes, it's very useful. Like this, for example, I'll delete this parameter, delete another parameter, change this to something else. It's very useful. Or just the built-in Vim stuff where you delete everything inside. You don't need regex. Okay, so what? How would you do the equivalent of doing this? String to integer. How would you do this? Or maybe you don't. I don't know. I'm just curious. Yeah, but this is tree sitter. When I delete a parameter here, this is tree sitter. So it's language. It's in the context of the language. Keybinds. What do you mean? Keybinds. Like what? Okay, what keys would you press to select this part only? Replace all strings with integers. Yeah. Yeah, but Neovim, yeah. So Neovim also it has tree sitter. Like I'm using tree sitter right now. This is a tree sitter query that deletes this parameter. And there's also for like functions, but that doesn't really work that well. Because it usually brings with it some extra stuff here, which doesn't work that well. But you can do like inner function. Yeah, I usually use just the inner block stuff. It means select a word on the cursor and repeat a keybind to select multiple words. Okay, so like this. And then integer. I mean, I don't know. I find it liberating to be able to break things out into separate commands that you then can kind of connect however you want. It feels like I like that notion. I mean, sure, it might not be. It might be better or more productive maybe to just have, you know, the standard things that you actually need, you know. But I don't know. I like to have the creativity at my fingertips as well. I like the feeling of having that control. But how would you actually do it? Like, what do you mean? Do you have a key binding that changes string to integer? What do you mean? I don't understand. Like, what key bind do you have to select this paragraph, search for string and replace with integer? What kind of key bind is that? That doesn't exist. You have to do more than just pressing one key, right? Okay, I don't know. You would have to. I guess you would have to show me how you do it. Okay. Anyway, where are we here? Handle all possible. Right. So if we have anything else for now, I'm just gonna return null here. Oops. Return null. Have you used the... Yes, I know what the multi-cursor is. I'm saying what are the key presses you need to do in order to select this paragraph? Do you do it with the mouse? You just said that you do, like... I know what the multi-cursor... I know you can do this in like in VS Code. Like you can select here, you can click here, you can click here. Then, you know, delete everything, type in integer, and you would have integer on all the three things. With visual multi, I press Ctrl N to select more words on initial cursor and then hit a Vim motion. Okay, I'm not sure if I know what visual multi is. How do you enter that? V plus select words, then Shift C and repeat. Okay, so I press V AP string integer. Colon S slash string slash integer. You have to type integer somewhere. What do you mean? Shift C repeat. Okay. Or you can just search for string and do like this. I don't know. No field name function name for string stream in the parameter. Right. Okay. So we have, so now presumably we have this, we have the stream actually. So now we just need, this function here. Forward string stream. All right. We actually need this scope as well, and then the stream. So this would be a stream of strings. Okay. Actually, it needs to be a pointer. And then, I guess this potentially maybe could be an error. And then we do that. You just select the word in Helix, but how do you get it to change into something else? You have to type integer, right? You have to type something. Like you're omitting details. You're omitting like the process. I understand that to select the word string, you just select it, right? And then you have it selected, and now, I mean, I can do the same thing here. I can just select this and then press star to get all the strings. Although now it like matched these as well, which I don't want to have. But basically now I can press star, I have the strings. I can select here, select this, change into integer, and do this. Yeah, you have to type the output, yes. But then you also, how do you select the string? You have to select it somehow. Do you do it with the mouse or with, how do you get to the string? And how do you, like, okay, so then you have to select it somehow, do it 3 times to select the 3 things, and then now you can like replace all the things that you have kind of selected with whatever you want, right? Is that the thing? Because it's a little bit like you're saying like, yeah, I can just do it in 1 keystroke, but that's not the case. You have to do other stuff as well. Like I'm including all of the steps. Cyprus, where are you from? I'm from Sweden. Thank you. All right, so you want to have, let's say, you are self, yes, and then the scopes, and then we'll have the address, and you have to be a var, and there we go. All right, so now we just have to implement this here. like what I was getting at is that when you say, yeah, it's just a keybind, so I just press one button and we're done. That's not true. Like that's not entirely true. Like what I wanted to say was like, okay, well, if we compare the both, yeah, sure, you might do it in like less time or less keystrokes, but we're not comparing the same thing. Like you're just talking about the actual replacing. Like I could also prepare a keybind to do the thing. Like I could prepare all the steps beforehand, and now I can just press enter and we're done, you know. Or you know, I can select the string, press star, integer. I don't have to type integer several times, but I do have to go to the next places and press dot. But I don't have to go press before. I don't have to press 3 times to do it before. I can do it one time and then do a repeat on whatever action I did, which I find is a lot better than just having like a replace on several places, because maybe I don't want to do a replace, maybe I want to do some other action that I want to repeat multiple times, and I think that's better, to be honest. Yeah, story is great. It also matches like on the word, kind of like it as you could see there, like, wait, where was it? Over here. Yeah, so as you can see here, I can press star and it will match the word string. It won't match substrings of string. If I press star here when it's part of a word, it will match substrings. But if I press star on this, it will match only this without other identifiers like this. You can even see the regex being applied here. Yeah, okay, so, but let's say, so now I haven't, okay, let's say I'm over here. I search for string. Okay, now I'm on string. So now this is like equivalent, you have to get here somewhere, right? Now for you have to, before do to this, you have to like select the things. I don't have to do that. I can type integer directly, and then, well, I have to do this, and then I can do this, but then I have to press dot, and that's basically the only difference. I have to like repeat it with dot, but you still have to go down, you still have to go down and select these things. It's not that much of a difference, to be honest. The only thing is like I have to press dot. Yeah, I'm just trying to understand what is better with Helix in this specific situation. Like, it doesn't sound like it's that much better, to be honest. I would rather have repeatable action than just being able to replace in several places at once, which is probably possible in NeoVim, in Vim somehow. I just don't know. N? What do you mean? Also, another thing I think is quite nice is when you do when you want to do it in whole file, or you select one part and do this, because that's not really what you said as well. How do you do this? Like, can you even do this in Helix then? Like, can you select an area of the code and replace every part of something with something else in it? Because now you have to use regex, right? And that was kind of my question from the start, because you said that you would like, yeah, I have to go and select all the places and then do a replace. this is not really doing that. I'm just typing out what I want to replace and what I want to do it with, and then I can do, you know, regex to do matching. You know, if we have a function, let's say I want to replace I don't know, in compile error, if I have to do this a million times, I can do this, or yeah, this, and then we have something else, and then maybe until we get this, and then I can say, you know, I add something here, hello, or something at the end, you know, catch error, whatever, and I have to do it in all the files. So I can do it here. But if you, let's say you don't want to do it on all the things, you only want to do it on some of them, then you could do /c, and then you get this prompt where it's like, yeah, do it for this, and then it will go ahead and go to the next one, or it's done. Or you press N to kind of say, no, I don't want it on this line, I want it on maybe some other line or something like that. Now that one I think is quite nice. I don't use it that much, but it's like, it's useful sometimes. It's like when you have to do those kind of major things, it's like it could save you huge amount of time. I don't know. And I realized that like Git, or not Git, well, Git as well, I guess, but Vim has so much, you know, under the hood that I don't know about yet. That if you know, you're talking about, yeah, you didn't know about star. That's one thing that is like such a useful tool to have, and if you don't know it, then you're like missing out. And you know, I'm not saying that you should go and learn everything about Vim, but just I'm saying like go and you know, check out some of the features some of the time, and you would learn something new that you can like incorporate into your current workflow, which will also like, because in Vim everything is like you can compose and you can do all these sorts of things. If you get really good at it, you can like, yeah, you can like do some incredible things. Anyway, forward string shape. So what do we do here? We get the forward context with scopes, get forward context. Now this will be a description of standard out, standard error that we need to pipe into. So yes, but does it have /c that it will question you every line if you want to replace it or not? Okay, so you do have replacements. Or is that MAF? What does that do? Does that replace in a paragraph or in like a block of text, or what does that do, Flawless? Hello Penguin, welcome back. Okay, so now basically what we do is, I guess we'll just do while stream next, we get a string out, right? Well, it doesn't really say here, but we should get a string. It could be an error as well. Well, if it's an error, we wanna catch it actually. Actually, can you have like a block? I've never tried this. Can you have a block that you can then catch? Is this a thing? No. Because I don't want to have to catch in here. Well, okay, whatever. Let's just catch in here. If we catch an error, we will... I guess we can just log. Error streaming. Error reading string. And then we just return. Whoops. Okay, so maybe this won't. No, we'll do try here, I guess. Select around a function. Okay, I can do that as well. Well, the tree sitter like around a function doesn't work too well actually, because it automatically selects a little bit more, but it does work usually. But if you want to incorporate it into a string or into an expression, then like an automatic expression, then it's a little bit weird. Helix motions are reversed from Vim mostly. It goes from intent to context rather than context to intent. MF star for each one to confirm. Okay, cool. So it is trying to like reinvent the Vim style, but in a different way, I guess. No, but I think it's something wrong with my selection. There's something wrong with my text object. Like it automatically includes. Also, when I do this, it's like this. The white space is not proper. Like inner function works, outer function takes the next thing as well. So there's something with my text object that's wrong. Like if we do inspect tree, oops, inspect tree, please. We have function somewhere. That's the next one. So here's this function. I mean, I'm sure this actually, yeah, it's correct here. There's something wrong with my binding. Yeah, select text object. Yeah, there's something weird with that. So it might be like the tree sitter is not, it's not wrong. The tree sitter is correct, but it's my algorithm for like selecting the thing that is wrong, because I don't remember if I made my own thing there, which I probably did. So that's probably why it's wrong. But you saw that the function declaration was correct. It did select this correctly, like in the tree sitter inspection. It's just that my text object is defined incorrectly. Okay. String. So let's see. Okay, yeah, so we'll just forward this to standard out. Now you have to be materialized. I'm pretty sure this always gets us materialized. Yeah. So I wonder why we should get like a materialized. That is type materialized. There we go. It's a joke if NeoVim is the modern Vim, Helix is post-modern. Right. Okay, so we will just write this out. Write all string. And then we're done. Okay, so now we've forwarded it to the string stream. Now let's see what we have here. Switch on stream. Yeah, it's gonna be source. I wonder if it actually gets the correct pointer here now, because we don't take the address. I guess we don't need, maybe. Invalid operands, binary expression, optional. Ah, so that doesn't work. Okay, I guess we can do like index +1. Is there a wait? If there, does this work? No. Oops, lazy. Let's do equals index +1. Sure, why not? I guess we could have also called this function actually. But it was still good that we did that thing. Forward string. Let's do standard out equals get standard out. No. And we'll do that. There we go. All right. Now, let's see if the thing works. So, what is this gonna output? We will see hello world, hopefully. This won't output anything, but this is now gonna output hello world, and then this will also output because it's echoing. Except, or it can leak and crash or something. Type mismatch. Wait. Wait. Oh, I see. S is a... Okay, well, let's do... Okay, let's do that then, because it's not... Okay. Like, we cannot reassign S to a different type, I think. So, there we go. Right. Okay. So now, if we do... Well, actually, let's do like test 4. Okay, so this is officially now the hello world in Runic. Maybe. Whoops. I mean, we could even do this. Hey, let's do /n so we get a nice... Or, okay, that didn't work. What? Don't we have this parsing here? I guess we don't. Okay, well, never mind. Actually, maybe, can we do this? I think this is a parser error, actually. Yeah, this doesn't work. Okay, that works. So that's the hello world. You just have a string called hello world, and it works. How did you learn Zig? I just started using it. I saw like a little bit here and there on like YouTube and stuff, and then I just like, hey, this looks interesting, so I just started to use it. And yeah, basically, I mean, for Zig right now, like there's not a lot of, like the documentation is lacking in some areas. and there's not a lot of like support out there. Like if you search Stack Overflow or whatever, you're not gonna find a lot of Zig questions. So a lot of the things you have to like learn, you have to kind of explore yourself. But that's what I find. I like that. So I I kind of like having to explore and learn stuff on my own. I don't know if it's just me, but how did you replace words with what you yanked at your cursor without entering visual mode and paste? Well, let's see if I can. Okay. Replace words with what you yanked at your cursor without entering visual mode and paste. VEP. Okay, I'm gonna be honest, I didn't actually know you could do that. And that's amazing, because I've always done like this. So let's say I yank this, right? And I want to replace this with what I yanked. What I do is I do Control W and then Control R and then 0, which was the thing that I had, right? And then I get like an extra thing there. Wow, that's actually amazing. So yank. Holy crap, man. Okay, so I have to yank like E. Oh, I guess. I didn't know that. Wow, that is actually an upgrade. Because that's not an uncommon thing. Or, I mean, it's not super common, but it's like, it's common enough. I didn't know that. I just learned that you could do like yank Control 0 to get like the thing. I'm not sure if I did that though. I think I just did the dot thing, maybe. Like just this and, you know, replace. I don't know. I usually don't do that. I usually don't do like Control and 0. I didn't do that now. Yeah, that's really nice. I'm not sure if I'm gonna bind something to it. I would rather do it myself, but yeah, thank you. That is amazing. That is an amazing thing. I never do that. See, like that's probably such a basic Vim thing, and I just didn't know about it because there are so many basic Vim things, basically. So I don't know. I thought about some time to go and like I watched some videos that was like, hey, here are some nice things, some basic things in Vim, and you know, some of it stuck and some of it didn't. But sometimes maybe I'll go and just read the whole thing. But that's a problem with Vim, like the Vim help thing. It's just there's so much stuff in there that, you know, you're never gonna be able to consume all of it. Like in one go. Like if you're trying to read and learn about Zig, Vim, that's probably not the way to do it. I don't know. I'm looking at languages to learn. I'm thinking either Ruby, Zig, or Go. Built a E2E encrypted notes app because there's legit zero that I trust. I have the features. Oh, I see. So you want like a online notes app thing that you can log on and get notes? That just, I mean, that, yeah. I mean, I would say Zig right now, if you're gonna build like a serious project in it, you're gonna have to also think about the fact that it's not fully conceived yet. So it's basically, if there's an update, major update, that's gonna be major changes, probably. So that's what you have to live with there. Ruby and Go are like, yeah, they have existed for ages, so they shouldn't do that. Zig is like, it's, you know, you have to live with major breaking changes, basically, in the foreseeable future, until they basically stabilize the language. So I wouldn't recommend it if you just want to be productive, but I would recommend it as like a learning experience if you just want to learn a new language that is interesting and has interesting things, new things. Since my clipboard is linked to yank, I use uppercase P to paste without yanking the place word. Right, okay. VEP is not dot replaceable, right? Really? Because you have to be selected first. Like this is one action and then uppercase P is another action. But maybe you can do... No, you can't. I mean, you can do this. You can do like, go back here, yank, star, go back, VEP, VEP, VEP. But I guess I would rather... then this is actually repeatable, like Control W, Control... No, not Control W, what am I saying? CW, Control R, 0, except it didn't do it. I didn't copy it correctly there. So CW, Control R, 0, escape. Now it's repeatable. And I kind of like that. I like Control R because sometimes you're in insert mode and Control R is a really nice way of not having to exit insert mode. And also it makes it repeatable like you saw there. Ruby is so slow though, but apparently the opposite. Okay, I've never actually used Ruby. I don't know. I try to stay away from Ruby actually because I don't know. There's something telling me in the back of my mind that I shouldn't use it. That I've had for like the longest time. I shouldn't learn Ruby. I don't know. Maybe it's the best language ever, but I would never know. Use TPO plugin for this. No. TPO has amazing plugins, but you should learn basic Vim things first, I think, before you're trying to use plugins for stuff. I've even installed, like, I had like the file tree stuff. Now I just use the built-in. I can do, you know, you get to the file system here. Now, granted, it's not nice, especially in my case here, because I'm using kind of like a weird WSL thing. So if I want to move things or copy things, there's like an issue sometimes with this. It's so weird. Like you have to mark files, and then you go out, which could be cool, you know. And then, but then you have to like mark a folder and then do like a copy action, and it will like copy it or move it or whatever. I mean, I guess it could be cool if you, but I usually just use the like terminal to do those kind of things instead of doing this. This is also not really a usual thing. The most usual thing I do here is create files and directories, which is very basic and it works very well. But one thing that I don't like is like going back and forth. If I go to here and I go back, of course I can go back here. If I do this and go back, it's like it doesn't work. Like I go back, I go out here. If I try to go back now with Control O, it goes into this weird thing, and then I go back here. I don't know. I just don't want to install something like a file tree because it just feels so unnecessary to me. Like I don't really do those kinds of things very often, so it doesn't really matter that much. If I want to delete the current file, I can do this and then BD to get rid of it from my buffer. It's not really a huge deal. Like those are the most common things, like removing the current file, removing it from the buffer list, going into here to create another file, going back, or a directory or whatever. It's really not a huge deal. Now, new. Yeah, I guess this could be good as well. Like you could, you know, this is the thing. Like there's so many options. So you could do this as well to like temporarily go out and do something, and then when you're done, you're just closing the buffer. I should really get into that. Or you can do tab new as well, and then you close this and you get back to where you were. But also okay, well, let's say you go back. How do you go back to where you were before? Let's say I go back in here. So now I want to go back in history, right? Well, I guess I can go back here, but then I go here and it stops working. I don't know. Anyway, and that's just the built-in stuff. That's just Vim building. I haven't done anything for that. Like that's how it works. That's like, this is this is built in, and then, you know, you go, this is all built in, and Control O is built in, and then it doesn't work. Okay, anyway. Yeah, okay. So what was the issue here actually? Did we have an issue, or no? We don't have issues. Well, I guess this is one issue. Like it doesn't like do this properly. This should be a new line and not that. I don't have a proper mapper for that. Maybe this should be the next step here. In which step does it make sense to change that? The parser? Well, not sure actually. Maybe when we evaluate it. Literal, yeah, and then string. I'm also trying to get better at Flash to move around more easily. I also like this, like fuzzy search. Like this is compare. So if I just want to go to render, if I knew it had this name, I could search like this, press tab, and then it would go there, which I love fuzzy search finding. Is amazing. And completions. All right, see you later, Flawless. Thanks for joining. Hope we can talk more about Helix when you have more experience as well, and we can compare. All right, have a good one. Okay. Yeah, compare like one of the essential plugins that I basically have. So, but you can't do, you know, Omni complete or whatever. But now it actually, well, what is this? This is this is like the actual Omni complete thing, I think. But couldn't you set the function? I thought it used compare. Okay, whatever. LSP Omnifunk. Okay, whatever. Anyway, yeah, so if we have a text, we do that. But the payload needs to be like formatted, I guess, now. Or decoded, maybe, you could say. So let's have like decode string. But that would change the string. Maybe we could send a writer in. Yeah, let's just send this as like, because you can, I think you can make a writer, but this is like the old, this is deprecated. I wish they would make this into the actual interface, because you can do like writer, there's like allocating writer, but then I'm not sure if there's like array list. Writable array. What is that? Asserts the provider buffer has total capacity enough for length. Advances the buffer. Wait. What is this? Writable slice. Greedy length. Oh, so that's just a thing there. Advances the buffer end position by length. I have no idea what this is, what the purpose of this is. Writable array, and it gives you, oh, it's like it's giving you an array that you can write into with the length. Oh, from the buffer. I see. Okay. I was like, wait, can you do like any type here? Because writers and readers only work with like bytes, which I guess technically we could actually make them work with maybe other types as well, because bytes could be like a array of bytes could be turned into anything. I'm not sure if there are like built-in things for that though, like creating like a writer for any kind of type. That would be cool, but I'm not sure if that exists. But I was looking for if there were something like from array list or something like that. Wait, undo. Hashed, hashing, discarding. Yeah, I guess you can write. Yeah, you can write like bytes. Okay. Yeah. Okay. Sure. The function is inline to avoid dead code. Okay. Okay. Maybe we could use that in the stream then. Yeah. Okay. Well, anyway. Yeah, so you could get like a writer, buffer writer, but that is, as I said, like this is the deprecated version, so I don't want to use that. And there's also like the allocating writer, but it doesn't really mesh that well together with array list. So I'm thinking what I'm gonna do is I'm just gonna send this buffer in here together with decode string. So that now we can say decode string will be, let's get the, so this would be like the dynamic string, you know, which is a pointer to array list. Oh, it's managed. Okay, fine. And then we get the encoded string, and we return nothing, or an error, or nothing. Okay, so yeah, I guess we'll look through encoded string and get the thing out. And then basically we want to check if this is that. We can also, okay, let's do this. Get next is equal to encoded string if I is less than encoded length minus 1, we will get the next one, otherwise null. So now this is a optional byte, and next is equal to n, whoops, no, n. Then we will increase I by 1. We will continue. Wait, can you actually do that? No, we have to have like a while, actually. We have to have a while I is less than encoded string length. And then we can have a continuation function that always does that. And character is going to be this. Actually, also what we could do instead is we could say 2 is equal to encoded string. Actually, let's call this the tail, maybe. No, that's not the tail, but it's basically the rest, or man. What would this be? The part rest? Okay, let's call it rest, whatever. Because rest implies that we have something else, which we don't. So, and then that's the character we don't have next. we will say if standard mem equal rest, if rest equals this, then we do stuff. We jump over that and we say dynamic string append new line. Try. Continue. Otherwise, we just append the character and we're done. Now you could add like tab, and I guess we could add support for that as well. And basically, since they are, well, we can't really, no, we can't put this in, we can't like dynamically create this, I don't think. We have to sort of match it like this. B shouldn't really work though, right? Or whatever. No one has support for that. /R, sure, why not? What else is there? Whatever. Let's just start here. Oh, that doesn't even work. Okay, sure. Okay, so now the strings should be encoded or decoded. Let's go back here. Let's see if this still works. Yes, and then we add this. And there we go. Now it works. Cool. And then we can have like tab. Whoops. Okay, that didn't work. Wait, why did that not work? Don't we have, doesn't this work? That's weird. What about /R? What the hell? If this is that, then we do this. Otherwise, we check for T, right? What's going on? Oh, wait, I see. We have to have like an ending here. Yeah, okay. So basically, we compare this to n, that should be like to 2, right? There we go. We should only grab like 2 items here. There we go. So now it should work. All right. Okay, except it looks weird now. What the hell? Oh wait, so this only goes back. Okay, so then you have to do this, I guess. Okay, there we go. Wait, can you actually do... But n does both. Or does it? What? Out of bounds? Oh, I see. Out of bounds because rest could have lesser things. I would say if the length is less than 2, we will do this and break. Okay. There we go. Okay, so /n actually, you know, goes back as well. So there's no point in doing /r/n, even though it's technically maybe more correct. So basically when you get here, /n should only go here, like if it's, you know, proper old style, I guess, terminal. But then, or is that the case though? But why would you need /r at all if you only need /n in that case? Like /r only goes back like this. See, it like overrides this here. Okay, anyway, cool. Actually, I just realized we could probably make a game, terminal game with this now. With like the ANSI codes and stuff. Like you could put like ANSI, like, or the CSI. No, because we don't have Unicode, or we don't have, yeah, we don't have like byte escape codes. We could implement that though. Okay, anyway, now we have basically, you know, let's rename this to hello world. And yeah, that is Runic hello world. We'll add a thing there. That is what. Okay, that's the first like actual complete example now. If this is gonna be kept in, I think so. This is pretty cool. Okay, so let's go to do here. What should we do? It would be cool to support arrays as well. Let's go to evaluator, and then we'll go to transform thing. So if we have an array, I think it's a ref. Yeah. And we grab that out. Or else we can't do anything. And this array is, of course, an array of values. Now, really the values are gonna be kind of the same thing. Maybe we should actually make like a transformer stream. I mean, actually, this could be... This can't be turned into a string, but it could be turned into a stream. But then we wouldn't really need... So this stream string from value. Yeah, that would imply we create a stream of transform first, and then we can pipe it into a stream of strings. The source will be... Okay, so maybe we actually want two values. Like input and output. Let's just go with it and see how far we'll get here. Input and out. Welcome back, Penguin. Okay, input output. So buffered stream. That is, so that's just gonna be like, we have this, yeah, that's just out there. I'm just trying to figure out what makes sense here. So next is what we get out. Well, this whole thing kind of reminds me of the whole observable pattern, to be honest. Which is probably, maybe that's where I want to go with this, like observables. Actually. Yeah, that makes a lot of sense. Because then you can connect them to input, output. Yeah. Yeah, I think I want to make like observables. I'm just gonna refill my coffee. I'll be right back. Yeah. All right. Okay, well, it's time to make a new thing. Observable. Very good. Okay. So, observables, the observable pattern is basically you have an observable that you can subscribe to. I think this makes sense. Like you observable. Yeah, but it is basically a stream of data. Because technically, you know, let's say you do the tail F something. You're basically waiting for an event, which is the write event of some log somewhere, and then when that happens, it will output some more data. So, like essentially, observables are nice when, you know, there's something that, I mean, it's basically like a stream, right? Except you subscribe to it to be able to like receive data. Stream should be enough. I mean, the reason why I wanted to go for like observables was basically, I don't know, it kind of feels like they are sort of this, it's kind of, they share a lot of things in common. I mean, I'm not sure if this is gonna fit 100%. Yeah, I mean, I hear you. An observable is also a stream. Like, it's a stream as well. It's just that, you know, it's just a different name basically, and it has, I guess, other implications maybe. I'm not sure. Because basically, what I wanted to have was, you could, let's say you have some kind of generator, and this generator is piped into some kind of transformer or something, and then we get the, you know, processor that processes the output, something like this. You know, this is the usual kind of thing. And observables, I mean, they are streams. Like, you connect it to you. And what's happening here is, like, let's say this is an observable, this is an observable, this is an observable. This is an observable because when you connect to it, it will generate some kind of output to you, for you. And it will be passed into the transformer, which then also transforms the thing and outputs another thing into the processor, which will do something with it. And in this case, maybe not produce something, but actually just maybe it just produces a complete event or something like that. But basically, observables are also, they usually have, like, you have an error, you can error, or they can complete. Well, it's just like a stream in that sense as well. You can think of observables as being more like a set of streams, but here you care about a single stream at a time. Well, an observable can be a set of streams, but it can also be just a stream as well. Like, that's the thing. It's like more powerful, I guess. You can have an observable of observables, which will be a set of streams as well. Well, I guess what you're saying is, okay, I guess what you're saying is that this is an observable, and then the stream is when you subscribe to it, then you create the stream. I mean, I guess that depends on how you define the stream. To me, stream is more abstract. It's just something that happens. Like, it's just that you have some sort of source that can push more than one value out, basically. Or, well, push. I say push, but basically you can get more than one value out of it. Because technically, even if you're saying it's a stream, in the technical like implementation of the stream, you would have to buffer a little bit, and then, well, or have to, but the operating system has to receive data from another process, and then it would have to buffer it somewhere in order for it to be able to be consumed by the next process. I mean, that's just technical details. Like, I'm just saying that is this as an observable or is it just a stream? Because technically, if you have a function, that could be thought of maybe then as an observable. As a function is an observable. If we could make that that type into something that we can reason about, I think that's just good. So if all functions are basically observables at that point instead, you could say. Because you call a function, then you produce a stream, right? That's an observable then, like in your own definition. So a function itself should be thought of as an observable in that case. Yeah, but I mean, just there's the whole thing where like, no, but each time you call a function, it's gonna produce a new stream, right? It's gonna, like, if you have you know, tail f, let's say we have a function void tail something, tail log f produces a string, and this would just be tail f server.log, and each time you call this function, it will produce a new string, and we will place this in something else.log, put it in the background like this. Each call here produces a stream, right? And this expression is basically subscribing to this. So this function itself is an observable because you can call it to produce a streamed output. I mean, basically, it's this, right? Yeah, tail has two streams. Well, in this case, it only has like, well, okay, yeah, sure. It has two streams technically because it's like reading from the file. vec3, where do you get vec3 from, Blue? Yeah, the built-in type at vector where you put like 10 f32. So this is vectorized automatically. like v u. Wait, no, that's the type. Like 1, 2, 3, 4, 5. Okay, these are vectorized, and now you can say v plus u, and this is a vectorized. This is a vectorized expression here. This will be turned into simd here. If you have vec3, let's say just vec3, you know, you would have like this. Or if you could also, like, you know, you could do this if you want to shorthand it. Whoops. Wait, why is it doing... Okay, whatever. So like x, y, z, that... If x3 is on graphic signal, no, it's likely to draw data pass to the GPU. Yeah, it's just the operations. Like these operations here, they are vectorized. They are turned into simd. But, you know, when you have vec3s, they are, you know, they are not that large. So, I don't know how much you're going to get out of that. But what I do, if I have like like in my physics engine in my game, I use like large lists of vectors that keeps all of the positions in the same vector, and then I do like an update on all of them at the same time. All right, well, back to this, because this is important here. I just want to agree that a function, essentially this function here is an observable. Because when you call it, it produces a stream of strings. It can fail, it can complete. It could potentially also receive, like if you change around the arguments here, we could also receive some kind of thing. Like let's say we connect a stream into standard in, and this would be you know, just cat, let's say. I mean, don't you have? I guess it's easier if you use if you don't want to like learn the whole thing with that. You could also you could read into quaternions, and I guess you would have like, you could do the matrix math and all that. But you could also like what language are you using? What game engine, or what are you, in what context are you doing this? I mean, I guess, okay, you're using Zig, I guess. I don't think math has matrices. Oh, there's complex, but there's no quaternions. So you could do complex, you could do rotation in 2D. Okay, anyway. So I think we probably want to have observables anyway. Like if it's a function is an observable, maybe we need observables. Okay, I was just thinking that okay, well, you know what, let's start with the stream. Let's start with the stream because that's probably what we need anyway. as well. So let's go to evaluator, and we have our little stream thing here, and I guess we'll take this as well. And all right. Because the problem I was trying to solve is I wanted to turn this into a stream of basically, because these are like arrays of values, right? So it's an array of values right now. So I wanted to, well, I don't really see it right now, but it's an array of values. Why is that not? Oh. Where is this? No, it's runtime. No? There's interpreter value. There we go. Alright. Okay. It's an array of values. So what I was thinking is, since values need to be transformed, I could create a stream of transformable things that is then piped into another stream that receives the transformed and just passes them through. Or we can just have a transform stream that has the like the array of values as a source. Yeah, I guess that makes way more sense actually. But that's why I wanted to have like in and out. So basically the in would be the buffer. I guess this would be like the same thing then. Alright, see you later, Penguin. Stream is high level anyways, you need to implement observables. So you once you get that, you could make a decision whether you actually need it. Yeah, I'm gonna try to continue with this and see. Maybe we are making an observable. We'll see. I just never found a use for observables, especially working with program input output. Okay. I see what you say there. Like, I've used observables before, and it just felt like a lot of. I mean, it's streamy and it's observability as well. We'll see though. I think I'm still correct in saying that a function is in itself kind of like an observable, because you basically call it once, then it's like subscribing to a stream, and you can also connect it to other things. I guess the connection part is what's really different here, because it's like, yeah, observables are only subscribable. You can't really put things into them. However, you can have a function that creates an observable which kind of wraps another observable, and then when the wrapper kind of receives a thing, it will kind of transform it and push it out with the other observable. Like, observables actually push data. Because when something happens, you call next inside the observable, which will push it out to the consumer. And the function will be called when there's new data to be had. Yeah. While as a stream, you kind of, well, The way that we've had this is kind of like an iterator where you request the next thing and you get it. Yeah. Because the observable, when you subscribe, you provide a callback function. It could make sense if we want to do the background processes. But those are probably just going to be their own threads or something. I'm not sure, actually. That would be a huge mess, though, maybe. I am not sure. Yeah, the stream is basically just an iterator. However, it's a bit different. Like, we have a stream. I want to have a stream that can take something in and put something out as well. So this buffer would be the in, but then it's just the same. The in and out is the same in the case of this. And then you could also potentially have some kind of transformer function. That's what I want to kind of be able to like compose as well. Like if you have the observable pattern, it's easy to like compose and do all that sort of stuff. I guess it could be for streams as well. I guess we'll see. Now this would just be the. I guess this would be like in and this would be out. It's the same thing here. This is this it's going to be the same type. And this would be out. But the thing is also, like, we don't know if the stream is done or not. Like, it has, if we call next and there's no next item, we have to wait until it's, you know, that's the thing. Like, we have to wait until there's available data, unless the stream hasn't closed yet, but there's no available data at the moment. It's a duplex. But isn't a duplex where you can both receive and send data? Like from the same, like between two like if you imagine 2 points of things that communicate with each other. Isn't that what a duplex is? Like they can receive and send data like a client-server thing. Yeah, so we have to have like we have to have if it's completed or not. As well. Yeah, it's bidirectional between the same things, but this is not really between the same things. This is like we're taking from one place, putting it into another place, which then outputs to a third place. There's 3 different like nodes in the graph. Whereas duplex feels like it's like between the same 2 nodes in a graph. I don't know. That's just my you know, initial thought about duplex. Because usually you talk about duplex in like networking. Yeah, they're sharing the channel. But what I mean is basically you have an input that puts into a machine that does something to the input and then outputs it to the next machine. So there's like it's like a pipeline. Of course, it's a pipeline, of course. I mean, yeah, it's a pipeline actually, but I wanted to kind of abstract it a little bit. I don't know. Well, let's just go with this. Let's just call it a stream. A stream is such an abstract concept anyway. Like, it doesn't feel like it has to be the way that we're talking about here. Like, it has to be a push, or I mean a pull. It could just as well be some like you subscribe to it as well. Like I don't feel like there's like such a like observable feels very like it has a very defined concept, but a stream It feels more abstract. Okay, so so let's say we init single with a value t. So let's say this is like any time. Well, no, this doesn't really make sense because we don't know what in and out is yet. We would have to, I guess. Well, I mean, I guess we just do this. And this is in, and this is in, out. We could potentially just provide a function, actually. No, this is still in, out. Yeah, next is out. I mean, yeah, we could have like transformed, put a transformer function in there. Yeah, basically, okay, what we're looking for is like a higher order stream is what I'm looking for. It's like you put a function in there that transforms the thing into something else. That is this is now a higher order stream. So basically this would be a transform stream. And then this would take another stream that takes in and out, and it produces another stream that takes in whatever thing that we want to produce, or whatever thing we want to take in. So, okay. Actually, let me. Should we make these into functions? Yeah. It makes sense to put these out here, actually. And I will make a simple stream that only has one type that returns a stream that's the same thing. Yeah, transform is a higher order stream because it takes another stream and transforms it. Okay, so then you are actually gonna be wait. Yeah, so you take comp time t. And this, of course, everything here is t now. Yeah, that makes a lot of sense, actually. So that's just that. Okay. And then you would be also a function. Man, fat fingers. And T. All right. Cool. And then I mean, we could make it into an interface, kind of, maybe. I'm not sure what's the best thing here. Because we're working with the generic types as well. It feels like whenever you add like these generic types, it's like if you don't have a very well-defined, rigid thing underneath, it's just like, it's gonna get messy. I don't know. Like working with interfaces feels like it allows you to do more things. But yeah, it's nice to have things typed, but then you can't talk about streams in general. now, unless you take like any type and does something. Just like here, like transform stream. Like what is this? Like this is a stream source or something, but then we have to have like in and out. No, this would be like, well, we'll figure it out. It doesn't matter actually, because it's gonna be the same. Okay, so what is the transform stream? We will take a stream S, which is a type. And I guess we could do some checking on that to see what it actually is, if we want. How we consider transform would be duplex, since it would have to implement both read and write functionality with separate buffers. Right. Yeah. Okay. In and out. Yeah, we can inspect this to get the in and out. We also need to transform. No, actually, well, okay, yeah. But this transform stream is now it's supposed to be very. It's supposed to be very like. See here, we can't really have this type right now. Because we need something else. We need the actual in and out. It's not really what's this is gonna be turned into. Like we need more. We need another variable here. That's like what are we transforming? What are we transforming from, or what are we transforming to? So this doesn't really work right now. I think we have to make this into an interface. And we kind of could. No, but we still need the type, I think. Also, if we have in, we have to have like a function. I guess we don't really need the in type. Maybe we don't need the in type, but then how do we connect to it though? This is the thing. If we have connected, we should already have a source, right? The source is the connection at the back. So we should already have that. Which in itself doesn't really have, like, this doesn't make sense to me. This should really just be like, what would be the type of, you know, a stream, which like stream 1 pipe to stream 2 pipe to stream 3? What type would this be? Like, this would be like, you know, you have this in and this out, maybe. Because then, how does that work? Because this should already have a source, so that doesn't make sense to connect it to something else. Like, you couldn't, I mean, stream 0 pipe to stream 1. How does that work? like, do we connect them? See, this is where I think an observable pattern is what we actually have here, because the streams themselves are already they're already like set up. So all you can do is look at their output and transform it to something else. I guess this would be the kind of the same thing. So basically, okay. I mean, really, I already have like kind of a system for this, actually. Maybe because I implemented like generic iterators in my other project, where you can map and filter and do all sorts of things with the iterators. So if we can like take that structure and have them also be able to like fail, maybe that could actually be a good pattern. Yeah, these are basically just readables right now. They are readables, except like they are basically like readers, except they work with types that are not U8s. But essentially what I want to have is I want to be able to pipe a... I mean, okay, so what is happening when you pipe here? What is happening when you pipe stream 1, pipe 2, stream 2? Basically, it's not really a stream, right, that you're piping into. You can pipe a stream into something. It's basically like saying, hey, I want to connect something that will try to consume the stream. But this wouldn't be a stream. This would be something that maybe transforms the thing, like consume the output, consume stream next function, right? And so it would just be like adding this is more the observable pattern, where you add like an event listener onto the thing. But otherwise you would have like a function that is like forward stream or something, and you take stream 1 and then you have some kind of context, and then you say like, well, while stream 1 next context forward push next, something like this, right? Because that's standard in, like we're pushing things into standard in, from standard out to standard in, from a reader to a writer. But the writer isn't really stored on the stream. The stream itself is only a reader. But then you connect it to a writer with something like a function like this, or some other mechanism. It's the glue between that's the problem here. Because also what happens if we're waiting for the next thing, like it doesn't we have to wait. So basically how we're doing it right now is we have the evaluator and we have or no, it's the executor, I think, maybe. Wait, where is it? Evaluator, run pipeline, which will run a stage. So here you can see, let's do executable. So here we're setting up the child process, right? Standard in, we don't handle streaming right now. But basically what I'm trying to say here is we have standard out, standard error buffers that we're allocating writers. So we have like allocating writers for standard out, standard error. We spawned a child and all that. So now it's like running. And we have some standard in. If we standard in is not streaming yet, so we just push everything into standard in right now. But then and here's like the outer context of where we should end up with the standard out, standard. And we have like streaming mode if we're streaming or not. And then we have these are we're reading, streamer reading from standard out. What the hell, this is wrong. Standard error. There we go. You didn't see that? Okay. So then and we have the writers to the action, like if we're streaming, we write out to the context, outer context. If we don't, or if we're not streaming, we're writing into the in-memory buffer and wait for the thing to and here's the loop. So this is the glue here. This is the glue which glues the streams together. So we check if the child is terminated. We have this. Basically what's happening here, I made this function here. It takes a reader and a writer. So it basically just reads from the reader, pushes it to the writer if there's anything to read. And we also get if we're closed or not. Alright. And this could be false, even though there's nothing to read. And the same thing here. So we kind of already have all this thing. It's just that it's very, very specific right now to like standard out, standard writers and readers. So what this function is doing is basically we're using the readers. This is the official like reader and writer here, and it has a stream function which will take a writer, and we're pushing unlimited whatever is available in the reader right now to the writer. And if there's an error which could be an end of stream, we return true because we want to see if it has ended. Otherwise there's some other kind of read error that is an actual error, so then we abort everything. But this would just push it through. If we have streamed anything, we flush it to the writer, which will push it out. And then one thing leads to another. Yes, but we're doing it for both standard out, standard error at the same time. Like if we just had like one stream, we wouldn't have to do it like this. But right now, yeah, both standard and standard out error, and then we're checking if they have closed, or if the child is terminated. Then we break, and we have to call this wait function for the child. But basically, this is kind of what we need, like this glue function here. But also we need to support like background processing for that as well. Like right now we don't have support for background processing as well, but then you would have to put this in like a thread or something. I'm not sure actually. You said you want to explore game dev, then why are you creating a scripting language? Well, I want to do both. Like I'm basically like I want to explore all kinds of programming things. Like I've been exploring all like kinds of programming things since I started to learn programming. Like I wanted to, like when I first started to learn programming, I wanted to make games, but you know that didn't go anywhere basically. And then I was very young as well, But I've been basically, I came to the conclusion that, hey, I just like programming. Like, that's what I like. I like to program things. And making a language is like, that is one of the things that is very, you know, programmy, because you're making a program language. No, but also like learning about how computers work, you know, and all that. So yeah, I will get back to the game dev stuff, but I'm just taking a little break right now to make this. I might start doing both at some point, but I don't know. Right now my mind is in this project here. All right. Yeah, so I just wanted to show that, how that works right now. So that's basically what I think is like, it doesn't make sense to have like the reader is kind of built into the stream, so it doesn't really make sense to have this in type, I don't think. I was thinking like, hey, it should be kind of like a function. It takes an in and it puts an out, so you can potentially connect something into it and it will put something out. But really, this is not a stream. This is like something that creates a stream, right? So I think we should just get rid of this and just have the T here. And of course, this is the reader type. And then this would be the value. I see. What's the IDE? This is NeoVim. Here. Yeah, it makes sense to just have one type here, actually. All right. Okay. Well, this would be T. Whoops. Yeah. And this is T as well. There we go. So then, basically, if you want to make make a transform stream, that's not a source. That is actually going to be just a transform stream. Takes a stream. Well, let's just make a function actually, like transform stream. It could be put onto the stream as well. Which would be, it would take some kind of function, transformer function. I'm gonna say any type for now. And then also like the stream, which is gonna be a, let's also say any type for now. Actually, let's just put it in here so that we can use the T. And this would create a new stream, which would be the result type of this function here. So this stream would be, it would be this. Self. And we will produce the return value, return type of the transformer function. So actually this is like a map. I will call this map. Let's just call it map like this. And this is the mapper, the map function. A little bit functional there for you. And yeah, we don't have return type. I think we should have it somewhere. Yeah, it's in here. I'll just move this. Or I wish you could put like runtime values in here. I don't think you can. function, like if you say any type here, and you do type of f, and then we put map function. I don't think this works. It's not going to be an issue right now though. Well, that's the type and return. I think it's going to be an issue later on. But then what's going to happen is we're going to return. Well, I guess it's going to have to be like a mapped stream. Yeah. We're going to have to create a new stream type. Let's just use u. Map stream. And this is the source, which is going to be a stream of t. Now the question is, should this be a pointer? I guess it has to be a pointer, maybe. Yeah, because otherwise there's going to be a dependency, circular dependency here. So it has to be a pointer. Yeah, and then we're just going to use the source for this. And then we're going to have the map function, which is a pointer to a function that takes... So now we have in and out, I think. Actually, we could even have the function itself here. Maybe, or is that supposed to be a pointer? Well, no, I think we could pretty much, whenever you have, well, no, it could be runtime known actually. Let's have it like this, so it's like more, whatever. And this would take a in and produce an out. And you would be a stream in, and the init would take the function and we would set that there, and then you would be out, which is like next source is that. If we don't get it, we'll return null. Otherwise, we'll return self map function on next source. Now the problem is, how do we create it here though? Yes, NeoVim. I said it. It's NeoVim. The text editor that I'm using is called NeoVim, or NVim for short, I guess. Is there a 2D at vector for matrices? Well, there's I mean, you can have whatever number of items you want in the vector. So this, you put the number of items here. So 2. Now this is a 2D. Or do you mean like a matrix? There's no built-in thing for matrices. But this will be a 2D, so you have an x and y here. You know, if x is 5, y is 3, or something like that. 3 point, whatever. Yeah. Now this is a 2D vector. It has 2 elements, x and y. But I don't think there's any matrices built into Zig. You have to. I think you have to use like a library for that. There should be a library, I think. I don't know, but probably. What are you using for rendering, Blue? So we can use it like a buffer. I mean, yeah, this vector is basically just an array. It's an array, so you can access, you know, you can access it like an array. And yeah, it is an array. So it's, if you want to use it as a buffer, or like you can turn it into a slice, kind of like this. Yeah, so, and you can even cast it into an array if you really want to do that. And you can cast it back. You can cast an array into a vector and vice versa, I think. Now the problem is here though, now we have this mapped thing, but how do I actually store this now as a source? Like this would be interesting. Because this has two arguments, in and out. We can't really have it as a stream. It would be like another type of streams, unless we add in and out now in everything. I mean, I guess we could, technically, maybe we could add that. Oh, I see. Matrix multiplication. Okay, okay. For a neural network. Okay. Yeah, yeah. You can just make your own matrix. Like you can just follow the procedure. It's probably not that difficult. But I mean, okay. Well, for neural network, like usually, I think usually you use something like the GPU to do a bunch of calculations. But I don't have much experience with that. But if you use Python, there's plenty of stuff, resources there you can use. But if you just want to get going with that. Well, this would really be a map stream. Maybe it doesn't really matter what we return. Like this would be a map stream. I mean, I guess we don't really need to know the input. So let's say we have a map function, return type of that, and then we return well, that's the problem. What do we return? We need to have a map stream. In is t, out is return type of map function. Source is self, and this is that. So really, you would have to get this map stream now. Like we can't really turn this into a stream, it feels like. Because you can't really have like, let's say from stream or something, and then you get like others, like you get like other stream is some kind of stream, or let's say any type, and then, or even any opaque, because then it wouldn't know which next function to call. I guess it would make sense with an interface then. Okay, but let's see, and then it's like, okay, well, let's say we return this, right? And then it's like, it's just, you know, well, I guess stream, other stream. That's a function. Return struct. Other stream is other stream. Next is gonna be return try self other stream next, right? We're just wrapping it. But and then this would just be like stream type of other stream. Other stream is other stream. Yeah, that's it. And that would give us a stream, a wrapped stream. Oops. No, this would be this. Or, yeah. Wait. No, we don't actually. Okay, yeah, no, we don't need this to be a const. Actually, or I mean, we need this to be a const only, and we can just do this. Actually, and then this would just be this. We're making the type out of the thing we put in here. So we're making this, we put the function in there like a closure, basically. And then we're just wrapping the original stream, and then we create a next function that will take the source from the source, it will map it, and that's what we get. Right? Okay. So basically, transformer. Right. So now we can do return. Actually, no. This, what we want to do is we want to say if this is a string, we do this. If we get down here, we will get like a compiler. Else if t is equal to stream of string, then we can make, if it's a string, no, yes, if it's a string, we'll just do in its single string. Oh, now we don't like, okay, we don't get like LSP from this because we don't know what t is. Well, we do know what t is, but it doesn't really work here. I'll let you know how I did it. Okay. I'll use Zig because I'm learning it. I already know how to make a neural network in Python. Okay, cool. I did one in TypeScript. Like the super basic one. What is it called? Stochastic gradient descent and what's it called? Man, it was a long time ago. Back propagation. Yeah, that's what it's called. Man, that really took a turn in my brain, like when I did that that time. I couldn't get like my head to understand like the full picture of the whole map, like maths operations and everything. Okay, if we get an array, we don't really get a string. Well, I mean, technically we could make it into a string, but I'm not going to do that right now. Here, what we want to do is we get this in it's a single. This one though will return first init. Well, first we need a stream of values, which we will initialize with a buffer, and we'll give it this buffer here, items. Okay, so, and then we map that. Actually, you know what, we need a pointer here actually, so we actually need like an allocator here. Ah, this is gonna be this issue here, man. Okay, well, I guess we could make refs potentially. We do need an allocator though. We do need an allocator, I'm pretty sure. Because basically this is going to be the source stream, which is going to be this, it's going to be allocator create a stream of values, and then source is equal to that. All right, so now we have the source, and then we'll return a map. Well, probably I'm gonna change this into an RC actually, but then we're gonna return the source.map. Why doesn't that work? That should work. Oh, it's out of memory. Okay. We can get an allocation error. Yes, now we can map this to anything we want, but this is going to be like transform transform. No, it's going to be, it's just transform. Yeah. However, we now need to have like an allocator here. So actually we need to like, we kind of need to pass an allocator in and store it here as in like for the closure, and then we have to like grab it out there as well to be able to call this function now. But you could make a version that doesn't need to have that, but yeah, we need to have it as a closure here basically. All right, now I mean we could generalize functions into be like closure functions. Now that we have like RC, it's gonna be easier as well. But the thing is also now we need to have the initialize functions on these streams actually. So we need a initialize function as well. And this would be void. And we just need to deinitialize the source. And that's it. All right. Now we'll make the source our seed so that it will properly clean up after itself. So let's grab mem from here, and we will do mem rc. Actually, let's just grab rc directly. So this would be actually we don't do this anymore. We do rc, and this is a stream of values ref dot init allocator value is init buffer array items options we don't need. All right, so that's the source. Don't need to do that. Okay, now, well, this is the ref, and then the source would be source ref get. Oh yeah, try. There we go. Okay. Right. So now this source is a ref or an RC. So when we deinitialize, it has a deinitialize function now. So we can call deinitialize on it. It will basically destroy its own pointer so that we don't need to worry about cleaning it up here. All right. And I guess we could do the same with the actual thing we return here, but nah. So yeah, now we have a stream of, we can turn an array into a stream of string. And we can also turn a string into a stream of string by using init single here. But basically an array of values into a stream of strings by using the transform function again on all the values where the source is just a buffer of the items in the array and the stream is like transforming this buffer with the transform function, which then will be called, this will be called with, oh shit, I guess we need this now as well. Okay, you know what? Let's make transformer into a function that takes t, which is the result. Okay, so now t is, we don't need t here anymore. We have t like baked in here. But now we can't use t to transform, like, because t is now, we can't use this transformer. We have to use transformer into a string. There we go. You could have also made like a partial function application, but this works as well. So we're making a new transformer that's supposed to transform things into a string. Okay. Now let's see if it works. Where is the thing? Where's our dear old stuff? You can use Zig in Windows. I can even cross-compile to Windows. And I have NeoVim. No, NeoVim should be available on Windows. I'm pretty sure. Alright, let's get stream and transformer. Okay. So yes, basically from value, I mean really this could actually just use return transformer of a stream, like transform, like I just want this transform, and we do need allocator and the value, but that's it. Like we can just return that and that should work. And we do need allocator, so I'm just gonna say do we have like, no, we have to use this one. Alright, so that's that, and we forward it, and then at the end now we actually have to deinitialize this. Actually, well, wait, what's happening here? What? Map. This returns a stream, right? Yeah. But it's like, okay, so this isn't really a stream. Right. Maybe we have to have an interface for this. Okay, let's just make it into an interface to make this work here. But then basically, how would we deal with this type? Which I guess we probably would have this anyway then. Because really what's happening is like this source we can't really put this into the source because it's like already a type. And that's why I think interfaces would work better, because we don't need to know the types beforehand. Yeah. Okay, so let's make it into an interface instead. Alright, so we know that these are supposed to be on everything. This is kind of already laid out as an interface. The only difference is now we remove this, and we don't really have a stream source. And what we do is we will say that we have a v table, which is a constant v table, and we have this v table, which has a bunch of functions. So this should have like next, which is a constant pointer to a function that will take nothing, and it returns a stream error or an optional t. Alright, and then we also have a deinitialize function that is also a function that takes no, actually it does take something. It takes the context, which is the stream t. That's right. And then this would just be void. There we go. Alright, and then we can remove all these things. Let's just remove. Init failed might be good to have though, maybe. Yeah. But init failed, because then we don't know the v table. I guess we'll have like a failed. Actually, yeah, we'll just make an interface that is the failed stream. Yeah. Okay. Also, I'll move you out because you are just a utility thing. Okay, map is probably, yeah, that's gonna be good. This one is just an experiment. Okay. Transformer, I'll probably just, yeah, let's just move this out. Value. There we go. Transformer. Right, we need allocator. All right. Okay, so actually next we'll just call self vtable next self, yeah, return. Okay, and then what's this? Actually, we'll catch this, and then I guess we could store the error as well to be there, maybe. And then no, actually we don't really care about the error. So we return like a stream fail or something, or fail stream t, and no, you would actually have a pointer here. So now this won't work. Or will it actually? No, it will work actually. So yeah, so first we create the RC. So this would be the failed stream is RC of a failed stream, and then we initialize that, and or ref, yeah. And we'll initialize it with yeah, it's just that. And you need allocator and the value and options. All right, so that's our failed stream there. That's the ref. And then we get the failed stream value out like that. It should work, unless there's an allocation error. And then we will say, so yeah, so this could error it with something there. And then we would say like failed stream, and then we need to get like the underlying stream. So I think it's just gonna be like the stream. Yeah. All right, but we need to create this type. So, whoops, failed stream sometime t. Hello, Bob Ross RTX. Welcome. How's it going? Fade stream returns. Wait. Yeah, a type. So we will have a stream, which is a stream of t. Not a pointer. And then we'll have, well, we don't really have anything. We have a function next. Self is a pointer to stream. And we will return a maybe that, or a stream error. And basically this is just gonna be, first we need to get the parent, get parent of stream t, which returns a failed stream t, and this returns field parent pointer, field name is stream, and the pointer is self. Okay, and so we will get the parent. No, we call get parent on self, and then stream yeah, we just return the error, I guess. Except we don't really need to go through the parent to get the error. Yeah, we could just do, this doesn't even need to be an interface. This just needs to be a vtable actually. Yeah, okay, well, let's do Well, or does it? No, I don't think so. Yeah, we just return self.error. And then we have the initialize. What does that do actually? I don't think we need to do anything with that. Like the thing we need to deinitialize is the ref. We need to deinitialize the ref. But how? We need a reference to the ref somehow. We need to store it on the thing itself. Doing it. I see you making a language as well. Oh yeah. What kind of language are you making? I'm just thinking about like what we could do. We could just populate some kind of field on fail stream with this ref, and then have the deinitialize that. Like what you could have the ref here, which would be the RC of the failed stream, or actually this RC of ref, and then the initialize would actually just well, this is just a void, and then this would be self-ref initialize, or well, it would be get pointer. So now we actually do need the parent. SVT, and this would be feed. Yeah, it would be this pointer. So now return field parent pointer, stream, and self. And we actually do need stream now. There. Okay, so now we have the stream, we have the ref. So basically we could go in and we can delete the ref by saying self ref initialize. Well, okay. Get parent self ref initialize. Alright, so that will deinitialize the thing. So all we need to pass around is a pointer to the stream itself, which is not going to be a pointer here. That's right, that's not a pointer. There we go. Okay, and then because what's happening here is basically this is going to create a pointer to a failed stream, which then also includes the stream and the ref. But we need to fill in those things. So here we have like the init function. I'm just gonna say that we need like an underlying stream. Actually, we don't even need that. We just need, well, ref is undefined, so you have to populate that later. And stream is basically also undefined. We don't really need anything to be there. Actually, we do. I'm just joking here. We do need something to be there. We need the error to be stream error, and I don't really know. Like we should, maybe we put the error here, and that is the error that we get to have here. So this is basically just initializing a failed stream, and it keeps some kind of error that it returns every time you try to call next, basically. Okay, if we fail to get the source functioning there. Okay, so now what's gonna happen here is we say stream error invalid source. Currently building compiler interpreter built on top of a custom architecture VM. It has its own custom ISA and will eventually have a front-end language built on top of that called Demi. Wow, that sounds very interesting. Custom architecture VM. What is ISA? I haven't heard of that. Assembly language. Okay, okay. So it's like your own assembly language. That's cool. I actually also made an assembly language, but it was very super basic. It was just to get some kind of hello world example working. Basically, well, a little bit more than that, but not really anything serious. But it was fun building it. But I will say the IA 8664 is complicated. But it was fun learning. Are you what kind of target architectures? Okay, but you have a custom architecture VM, so you don't have to deal with. Or do you have to deal with the CPUs and stuff? At the moment, there will be a top-level language built on top of that will be designed to be a fully customizable language, almost like design your own. Oh man, that is awesome, man! I thought about that. Like, are you able to create your like? I wish there was a language like that, like where you could like create your own syntax or anything. Is it like that, or? I mean, I guess. That sounds really cool. It sounds like the language of languages. It's interpretable once the assembly language is complete and gonna work on x86-64 translation. Okay. Awesome. Yeah, good luck with that. That sounds really awesome. So it can be compiled into native machine code. Yeah. Man, that's really cool. Holy shit. Okay, so let's see. Fail stream, yes, we do that. Okay, and then we also have to populate it now. So this would be we have to populate ref, otherwise this is gonna crash and burn. So this is gonna be, I'm copying over the ref there. That's fine, because that's fine. And then we return the pointer to the stream, so that's the pointer there. Okay. Now we're trying to make a thing. Well, this is wrong though. This. Well, first of all, this is like an optional, so we could also have like or else. Catch. It could be an error, and it also could be a nullable, but I don't want to have to repeat this. So we'll put this in it failed here. Currently got 322 passing tests to rule out different edge cases. Wow. Is it available on GitHub or anything? All right. Yeah, we need some kind of error to return. And that should be it. Actually, we need allocator as well. Awesome. Nice name, by the way. Is that your actual name, or is it a coincidence? Yeah. Cool. Are you okay? A question: are you making it all by hand? How long did this take? You've been going for like a year almost. 8 months. Okay, cool. No LVM, no nothing. Okay. I was thinking more like AI. Wow, this is awesome, man. I'm guessing no. The only outside lib I use is FMT C++ network. Huh. Alright. I don't know what that is. Is AI for refining cross-reference documentation would rather write the code, not use the code. Yeah, I will say that AI is like, I mean, it's good for certain tasks, but it's I've stopped using it. I tried it a little bit to jumpstart this project, but I stopped using it because it didn't work too well, to be honest. But it is good for certain tasks, like boilerplate. I asked it to add a bunch of logging to one of the things, and it did a pretty good job there. And yeah, some stuff like that. Or finding, maybe put it to find. Hey, could you find this? This bug is bothering me. Could you look for that? If I feel like it's like a bug where it's gonna take so long to find or something like that. FMT library is just for formatting terminal output. Oh, okay. And yeah, documentation. And yeah, it is pretty good for maybe. Well, even the documentation sometimes. Because I hate like fill out text. I need it to be concise and compact or concise and informative, basically. That is a good documentation. But AI basically it just puts a bunch of stuff in there. But yeah. I guess you could. I could also get better at using AI, to be honest. It usually does what you try to tell it to, but yeah. Yeah, debugging is cool. Okay, let's see what's going on here. Right, so this has the wrong return type. This is like a thing. So I think. I mean, really, this should be a pointer, actually. Yeah, because now streams, this is like an interface, so this has to be like a pointer. You can't return like a stream on its own. That doesn't work. So we have to use pointers now, which is fine. We have allocator. Here we're gonna create a single stream. And that is gonna be, actually this kind of have to be like our seed now. Also, what's good about this is that we can actually make this into a string ref actually. Yeah, that actually worked out pretty well here. We can make a ref, and then we just have a ref that you can deinitialize as well. Yeah. So we don't have to worry about anything, basically. I mean, it doesn't really matter. This string, it will live throughout this, I guess. Yeah, okay, whatever. Single stream ref. I mean, for this one, it will, but maybe not for other things, actually. We can always change it later. All right, so you will be a stream of this. Actually, hang on. No, it's in the single. This will try to do that, actually. Yeah. Yeah, I think all these should return an RC actually. Like it should just be built into the whole thing. Yeah. Single takes item T, returns that. We have the single stream ref. This is a single stream. We initialize it with the item. We will, oops, I forgot to do that. I find AI to be quite concise with writing documentation, especially if you're specific in your prompts on where documentation should focus. Right, okay. Yeah, I'm just using it wrong then. I've been working on this project as a whole for about 2 years now. Oh, wow. Started off with good job, man. Started off with an interpreter demo of the top level language in TypeScript just to get an idea to play. Then I restarted it around April to start building the compiler. Wow, really nice work, man. That's awesome. I hope it goes well. It sounds amazing. Alright. So, okay. I mean, okay, so how does it work? Like, do you create like a specification of your language and then you can use it like in the same source, or well, I guess you have like examples here. Are the examples like basic? Oh, that's just assembler. I guess this is your assembly language. Well, you don't see what I'm showing here. Let's see. Is this your assembly language here? All right, cool. Okay. Right, so we have like some data here, and starting address is OX50. We got like a label. This is the I guess this is a data type. 10 length. What's, oh, I see, this is like a new line or something. New line 0. All right, start. Right, I always thought that .text was a weird name for the instructions. Print string using outstar. There's probably some kind of history behind that. Essentially, top level language should have a set of base rules, work as fixed language in a way. It will work as a fixed language in a way that it will have a encode configuration where you can configure wrappers, which are kind of like aliases for existing functionality. Okay, cool. Oh, okay. So this is like the different. I was looking for like examples. Okay, this is assembly examples. Examples of the demi language. Or is the demi language the assembly language? No, wait. The language will have a default if statement. Then inside the config we define a custom if statement, custom syntax. Right. Okay. The demo language is made. Ah, I see. Right. Out string. Okay, you have like a special thing for this. Cool. If you look in the README, there's a roadmap. Oh, nice. Okay, well, it looks really cool. Oh, yeah, because it's a virtual machine, right? Yeah. Well, so is the assembly work? Is the assembly working in the assembly or the virtual machine? Okay, yeah, of course. You said before that it wasn't compiled, right? Right. All right, cool. Awesome. Yeah, I really hope that you continue with that. Or, yeah. That looks really cool. Where were we? So we create this ref. We will. So basically, it's kind of the same pattern every time, I guess. It's just changing the initialize here. So you would need the underlying string, and then we also need the ref. This line is gonna be repeated over and over. And string as well. And then like get parent. Is also gonna be exactly the same. The only thing that's changing is like what this means. Assembly works in the VM in a couple of months. We starting the native x86-64 code generation, which is translate custom to native machine code. Cool. So it will offer the opportunity to debug in an interpreted manner. You can still get the performance of native execution. Awesome. Yeah, I mean, really cool way to. It's also cool. Like I thought about this also. Like maybe I shouldn't have tried to build everything at once. Like trying, because I've added like, you know, a type checker, LSP, and all that before I actually have like the basics of the language in place. But then it's like, okay, but it also helps me. It gives me a little bit of variation in the project. It also helps me keep on going to get some cool features in there. And but yeah, it also gives me a little bit of room to breathe, to think about how the language actually should work. But yeah, sometimes I felt like, okay, well, maybe it would have been better to, if you want to make like a, and also this is kind of like a toy language for me, or pet language, or whatever you call it. It's like, if you want to make like a serious language, maybe it's better to start with like a prototype of the actual like core language features and then build on top of that or something like that. I don't know. But then also it's like, okay, But what if you do want to have all these other things like the type checker and LSP, but then it's you might need to like rebuild a whole bunch of stuff when you don't know how to kind of build in support for those systems, basically. But yeah, once you know about like, okay, well, how do I go about to add support for those things? Like what would need to have support for those things? Then you kind of think about that in the process of making the language anyway. So it's a good exercise to do it, I guess. And then, you know, once you've made a full language, then you can make another one, a better one, I guess. I'm talking about myself here, by the way. I'm not talking about you per se. Yeah, that's what I've done with the TypeScript demo. Then the compiler, working on the entire toolchain from the ground up. Yeah, yeah, really cool. All right, so we have that stuff. Maybe we should add a function that kind of initializes the thing. No, we just have to copy this. All right. Oh yeah, we also need the initialize as well. But this one is, the initialize is actually going to be the same for all of the things. The only thing that changes is the parent. I guess this could this be a vtable thing? No, it can't. Because we need to know the type. But we know that. No, it needs to be comp time known. I was thinking like if we could generalize the initialize function and not having to like call it on every type. Actually, no, we can't. Because you can't have like a stream without the thing. It's not like the type is built into the function. I guess we could get the address to this function though. But then when you get this, you wouldn't know what this returns. No, but if you have the... Man, this is weird. Also, wait, the vtable. We need to do the vtable. Yeah. So this would be like... Oops. Yeah. I guess we have to live with it. Get parent self. Now this is string t. Wait. Ref thing. Yeah. Because it's gonna look the same. It's just that this is changing. No, I guess it's built into the function. If we could just put this in the vtable, right? It should be correct. Because this is gonna be correct. Yeah, it just needs to know which of the get parent it's supposed to call. Right. So if we put like get parent here, this takes that, but we don't know what the type is here. That's the problem, I guess. Yeah, okay, now. Once I get the ISA expansion complete, I want to start bringing in contributors, make it into a serious project. Oh, cool. Yeah, sounds like you got a serious project on your hands. That, yeah. I'm very interested into seeing how the language, what it looks like the demi language, because when you made it in TypeScript, is that what you thought it like? Is that how it's gonna look like when it's like done? Or the version that you did in TypeScript, was that like the demi but the prototype basically? Okay, so we have stream, we have ref. This is going to be the same on all of them. It's going to look the same. We have the v table. This is also going to look the same. We have the get parent. This is also going to be the same thing. The initialize also going to look the same. The only thing different is like next and init. So stream, ref, get parent, the initialize. Oh yeah, v table. We need the v table, that's right. V table, and also you need to be like that, and you as well. There we go. Okay, so buffer stream is done. This is done. Failed stream. Okay, I'll move you up here. Ref stream, yes. Init, get parents, yeah. Cool. All right. Okay. Now let's do init buffer. Buffer. Stream T, buffer, buffered stream, yeah, I like having the different names, even though there's like a similar pattern going on here, since then you can like kind of tell it apart a little bit more. Okay. Now we don't need to do all this stuff here. We can just say if we catch, we will return a failed. Okay. We actually need to say stream, or well, we need to say this init failed, and the error is stream error invalid source, else, or else. Is it or else first or catch first? No, it's catch first, right? And then or else. Init failed invalid source. So we just have, you know, two branches does the same thing basically. I don't know how to properly format this. Let's just do it like this, I guess. Because we could either get like an error or we could get... Okay, this is like initialization failed or something like this. I'm not sure actually what to call this. Init failed for some reason. Invalid source. What? Expected 2 arguments, found 1. Oh, I need allocator, I think, yeah. Essentially the prototype, but there's been a lot of changes to the plans for it and a lot of feature ideas to come to play. Right. Yeah, that sounds like it should be happening. Or I don't know what I'm saying. Plus there was a 6-month break period where I didn't touch it. Then I started compiling with a lot of changes in mind. Right. You let it boil a little bit. Came back with some new ideas. That's really good. Expected. Oh, wait. No, this is V table, that's right. This is a... No, wait, this is not V table. V table is equal to V table. There we go. Actually, we should also have like... There should be like a private initialize function or something. And it's gonna return a T. And you're gonna get a vtable here, and we return vtable. All right, and then this is gonna be like dot init vtable. So there we go. This is the thing we need. Alright. Alright. Cool. Alright, what is your issue here? Stream. Yeah, okay. That is correct, I guess. Guess we need to do that. Found maybe. Okay, well here we can just unwrap it because it should always be there. I guess it could be modified for some reason, which it shouldn't really. All right. Incompatible. No, you should return, yeah, pointer. Right, you return yeah, you have to be a pointer, that's right. That is right. Okay, so these are the only, well, it's the only thing in here, I guess. What's going on here? Expected pointer to stream string. What? Oh. Right. No, wait, that's not... Okay. So, I guess this would be like an RC error. Yeah. We can actually get an RC error here. Fine. That's gonna be on all of those. What else? This is also an RC error, I think. I think it can't be really anything else. Cannot assign to a constant. Right, these need to be var. There we go. U. Expected optional. I thought this could be an optional. Found. Do we have to have or else first and then catch? No? I'm confused. Or do we have to wrap this maybe? Maybe we have to wrap this. No? Expected options. Oh, wait, no. Wait, yeah, okay, this needs to be try, that's right. And then this is also try. There we go. Right, because they could potentially fail with this. Alright, now let's see what's going on here. We got a couple of errors here. Right. We haven't finished this here. So now let's see. Well, you don't need to be like this. What we do is we basically, we can say well, it's not going to be a ref actually. We'll just do stream of value, because these are values, yeah, init buffer. So that's just gonna get us that. So this will give us the stream, and then we don't need to do that. And then we map it with a transformer transform to string. Okay. Well, allocator is unused. No, you need an allocator. Okay. And here we get the string. We do a single stream. That's gonna be stream of string in its single string that we just returned. And allocate. Expected out of memory, string found, invalid ref. Alright, so now you can, now this is like an RC error, so that's right. And you are also an allocator. And wait. What is happening? Expected type error or stream of string. Found stream of error or string. Oh, because of the return function of this. I mean, I guess it makes sense. Like every transformation could potentially be an error of some kind, I guess. It does make sense. So alright, so this is like an RC error union. There we go. Yeah, but now it's like, yeah, that's not the type that I wanted. So it's like we can't really get this. I mean, maybe we could actually, you know what? Maybe we could like flatten it so that when map calls this, we actually do like a try here. So that will kind of bubble it up, right? So no, wait, that doesn't work. No, wait, we could do like the salt is this, or if we catch an error, we would put the error into actually, okay, we need to change this a little bit. This is stream. We actually need a we need the thing here. Yeah, we need the thing here. So, and this would be no, but this is a pointer now. Yeah. We don't actually need this ref here. Mind-blowing that NeoVim cannot soft wrap to text with. You can't, for example, wrap lines to 80 constructs without using hard breaks, literal new lines. What do you mean? Okay, well, I think it has wrap, set, wrap, and what would this be like? No, I have no idea actually. What is wrap margin? Number of characters from the right. Window border where wrapping starts. When typing text beyond this limit, end of line will be inserted and inserting continues on the next line. Oh, I see. So, but this is like, this is not soft wrap though. Yeah, okay, so if I say like 50, I start to type. Okay, it doesn't actually do it. Okay, you can software, but can't set the maximum columns. Fix it for you. Set columns, but that sets it for an entire name window. Set columns. What's the difference? Does that change the size of the window? You gotta do what you gotta do. What's going on? Okay, so yeah, we just need to keep a pointer around. That's fine. There's a pointer to the source. That's fine. What would initialize? This would be stream initialize, but this is not really the same. Yeah, let's call this source. That's better. Initialize the source. Yes, we don't need to keep this as a pointer. Although, okay, in order for actually we do. In order for this to be a stream, actually we have to. So this has to be a pointer to a stream. Yeah, that's how it works. Right. So then actually we need stream as well, and the ref, and the vtable, and get parents, and init. All right. Not sure about allocator though. I don't think we need allocator because we have allocator on ref actually. Yeah. Don't need that. Yeah. We don't need allocator. We can inherit the allocator. Okay, so this is the type that we are getting. We could move this into its own thing. To be honest, like you could move it into its own type now. And this would be over here somewhere. But now, actually, this needs to be a function that takes in. Now we can have this and out. Return a type. Return this. Do that. Do this. T. So in here, first I will do that, and then in here I will do this, and then that's gonna be replaced with in, and then the out is gonna be like, well, this is gonna be a function that takes in and returns. Basically, this would have to be some kind of stream error optional out. Yeah, just to cover all the bases here. Cell name with the physical size it can't be within, including all URLs. Yeah, I guess. it would be annoying to write that plugin. I mean, you could add, maybe you could add like you could contribute to Vim and add that feature. Mapped stream, right? So in, out, yes. The function is that. I'll create this type here. In, out. This is a map function. Source is a stream of in. This is a stream out, actually. All right, and next, take the next of the source. We map it. Oh, we need allocator as well. Right? And we catch an error. If we get an error, we have to do self. Also, this is stream out. We have to do. Now this doesn't need to be underscore anymore. Although, yeah, parent is get parent self. So this would be parent instead. And the allocator is going to be self. No, it's going to be parent ref allocator. And I guess we have to try it as well. There we go. Okay, now you will be. Yeah, actually, we set the error here, and then we return the error. So if we got an error here, we have to set it and return. Okay, and otherwise we return the results, which also could be optional. I guess if it's null, what happens then? I guess it can't really be null. No, that was a stupid idea actually, now that I think about it. We should not have it be null or optional. Like if it's optional, it should, I guess if we make it optional, it's like it failed to transform it. But does that mean we should end the entire stream? I mean, no, I guess. So yeah, okay. So the stream is not really like an iterator in that sense. Like when you have a next that returns null, it might mean that we have not ended the stream, because you could look at if it's completed or not. Maybe actually we should, maybe actually next should return like an event. It's like a stream event. Or yeah. So this would be like a union enum. And we also need the T here. All right, so this would be, I guess next, or it could be completed, or it could be error. Well, if it's error, then we just return an error, I guess. So it could either be next or completed, or it could also be that we just didn't get an item. But I guess that is what null is, I guess. Okay, let's try this. What's happening here? All right, so return type. No. Okay, so this would be, this is the wrong type now. So this would be like a stream event of t instead. And this would be like the next value. And then this will be complete. Or just yeah, just this. There we go. You will be next. This actually returns completed now. And this one as well. We could also add it as an error, like that's how the built-in streams work. Or the reader thing is like, yeah, end of stream is an error. I don't know, I just feel like end of stream is not really an error. It's kind of weird that it's an error. It's just supposed to, yeah, whatever. We have this stream event. Let's try this pattern here. Okay, so the v table needs to change. You now are a stream event of t. There we go. Where's the next? You are also stream event of t. Okay, what are you complaining about? Value, stream event, const function value, returns error or stream event value found, stream, buffered stream. What? Oh, this needs to be stream error. And then we have like, yeah. There we go. I mean, I guess technically we could have another function. We could have like next inner. Next is stream, and this is now this. Which is stream event. And now it's like return get parent self next inner. Right? I mean, this could also be called next, to be honest. So let's duplicate. This is incorrect. It's not the same struct. Okay. I mean, it should be a different error message, I guess, maybe. Let's just call this next inner. Wait, what the hell is this? Failed. Right. Actually, we don't need this. What the hell? There we go. Right. Let's just set this to undefined. There we go. Same order, important. Consistency. Okay, let's look at this. Stream event, stream error. What is stream error actually? Let's add RC error here. Okay, so we need, you're saying self here, and then we get some kind of error, stream events. Okay, found single stream. All right, so this is the wrong, this is actually inner. There we go. Wait, this is the stream event. That's right. Okay. What's happening here? Found to there we go. Still issues. Okay. Right, so mapped stream. Okay. So basically, we need to do the same kind of thing, except, yeah, up here. It's like we're taking this. You are now buffered is mapped, and this is mapped stream. That takes this as an input now, and the output is going to be the return type of map function. And we also need an allocator here. Right, and you, right, where's the init, where's the mapped init? Oh. Okay, so we have the source. And we have the map function, and that's it, I think. There we go. Wait. Actually, we don't need to send the allocator. We can reuse the one on the ref. Except we don't know which one it is. We could implement an allocator interface function though. But that's a little bit annoying, to be honest. I mean, yeah, potentially we could add like an allocator, you know, get allocator, which is a function, stream t, gives us an allocator, or we could just pass it in, but let's, whatever, let's just do this. Or this could actually be an RC error. But now we have to create it, so but we can actually now say get allocator self is at this RC error. Return self vtable get allocator self. Alright, and now we can say self get allocator track. There we go. But now we need to implement a bunch of these things. Also, it can be an RC error. And you want the source, which is self, and then map function. All right, or not. Constant allocator value, bunch of errors. Oh wow. So we have like an error union, right? I think we want to maybe try and flatten the error somehow. Well, we need a type to be flattened as well. So flatten error or join error. Let's use some terminology here. So we have the let's do the result type. There. And we'll say that, well, this is going to be T, and it's going to be an error union. And then, yeah, we just return the payload, because basically we're just getting rid of, we're just getting the child out now. We don't know if it's an error or not. We're not checking that, but we can kind of assume that it's going to be that, because otherwise we would get some kind of error anyway. So let's do the join error there, and there. We could do like out is return type map function. So we don't get as many things in there. Okay, now what you're saying here is that we need a function, allocator value, return error, or double. Okay, well, we need to we need to join the optional as well. Oh man, let's just do like a special operation there, like map function results, which takes the function, and we return return type of f, and then we do join error and join optional. Okay, expected allocator value, error union. Oh yeah, we need to actually use it as well. So map function result of map function, and same thing here, map function result of map function. There we go. Okay, are we finally done with that? Out is not used. Let's remove that. Well, maybe. We'll see. Okay, so now we just need to create get allocator and everything. It's also going to look exactly the same, I think. let's put it over here. Get allocator stream of t. It's gonna be like an RC error, and we're gonna get an allocator out, hopefully, and it's gonna be just ref. No, get parent self ref allocator. There we go. And we just need to add this to every type now. Also, we need to add it to the v table as well. All right. And then all the v tables need get allocator equals get allocator. Come on, v table. All right. Okay, you are out. Anything else? Yes. Expected value found, stream event value. Right, okay. So now we actually can yeah, if we get null, we should return it. We can switch on it to see if we get completed. We will return complete. Well, we can return this, I guess. Return switch. If we got next, we got the next, I guess, like this. And I mean, I guess we could just return that. See how we can fix this here. U with me n. Okay, so here we go. So expected this found optional, right? So if this is optional, I guess no, wait, stream event. Oh yeah, stream event, that's right. So okay, so if we get it, we get the result, or else return null. And now we have to try as well. If we get the result, we just return it as next. Now there we go. A next event. Expected error unit up. Oh. Wait, I thought you could be an error. Actually, wait, no, we should have a stream. Yeah. All right. Okay. No field of function named in these things. Right. It's trying to call the initialize on them. Okay. That's actually a little bit annoying because this is also called the initialize. Can you have this? Can you make this function up here? Can you just make a function here? No, you can't. I mean, we can make a separate struct, I guess. This is like the util struct or something. I don't know. And then, but then we don't have get parent. But we can maybe name this as buffered stream underscore. Does that work? Okay, but the man. Welcome back, Penguin. Hang on, this is wrong. Like this should be, no, it's not. It's not wrong. It's not wrong. It should be this one. It's just that the naming is colliding here, which is extremely annoying. But okay, so what we could do, we could have a dnit inner, right? Which is the this type. And this would look the same as well, I think. Actually, we don't really need to initialize the child. So this doesn't do anything basically, actually. But what you can do is you can say, okay, well, the dnit function is gonna be dnit inner, which will call this. Actually, we need to do like without allocator. Oh. There we go. There we go. So basically, wait, no, there we go. Okay. So we pass an option that says that, hey, this is the initialize function for this. And I think the only thing we need to do is really, we actually need to clean, we need to destroy ourselves. So we can then, actually we could get an allocator. So with allocator, and then this would be allocator self allocator destroy self, and that's all we need to do. Unless we have like other stuff we need to clean up here. For buffer, for example, may be something we would need to want to clean up. But yeah, this is gonna be, I guess this is how we want to have it now instead. Because the RC will automatically try to call the initialize, but since there was no initialize, it failed, and we have to kind of, yeah. But we'll just copy this. The only reason we need to have the same over and over is basically because the types change. And there's not really a way to kind of share these with a separate type and have them be functions on this struct. Unfortunately. Or fortunately. Well, depends on how you see it. But. Alright, let's see what's happening now. Is there something weird with the syntax here somewhere, or what's happening? You are out. Oh. What the? Oh. Right. Return. There we go. Okay, okay. But you still complain. There's no dint function, but we're not trying to call it. We're setting this to be that. That is actually like a comp time thing. I'm pretty sure. Or maybe it's not. Wait, parents likes 1. No, but there is no dint function though. How does it get the parents length 1 if there is no dint function? Is it getting like the is it getting this one? Okay, you know what? This doesn't need to be called init, to be honest. This could be called you know, dnit interface or dnit stream or something. This could be called dnit stream actually. And then this can be called dnit. I don't know if it's supposed to be public though. And now we don't need to specify this. It will also we don't even need to, actually we don't even need to have this here, I don't think, to be fair, to be honest. But now you need to be dnit stream. There we go. Okay, now look at this. It disappeared. Okay, so we just need to, okay, it tried to match the dnit function that was like declared on the struct, but the struct, okay, I think it's because we don't check the self type actually. Maybe we should, yeah, we should actually check the self type. Is self params, well, okay, first we check if params length is more than 0. If it is, then we'll return 0 type equals star t. It should be yeah. Or I guess we could also check if it's t as well. Else false. So this would check like we need params. If the first param is like either, you know, a pointer to itself or itself, then it's, you know, it's a self function. Otherwise it's not a self function. So if that is false, we don't actually want to do this thing here. Return null. Yeah, if is not self, return null. Okay, however, Yeah, we still need to make sure it gets properly initialized, of course. But now we can name this init again, and I think we shouldn't get any errors now. Yeah, we don't get any errors. And we can go back to this. All right, cool. And you can be gone. All right. And we don't need you. That's right. All right, cool. Now we're down to this error. Man, it's a lot of changes here. It's always like when you do a lot of, well, it's not really changes, I guess. It's actually like a new thing. So expect this found that, yeah. Okay, so we'll do. What do we want to do with this one? I guess we'll try. If there's an error, it should just error out. Now, right, this is kind of weird. Like it still understands that it's supposed, like, from value. What if we do this? Will that work? It does work. Wow. Or does it? Wait, there should be a init. Void return self vtable deinitialize self. Oh, it does work. I didn't actually know this. Like, if you have a pointer, you can still use this pattern where you can, or can you actually? Maybe you can't, because this doesn't work. No. Okay, maybe you can't. It would be cool though if they could make that work. Expected type, doobie-doobie-doo, found, doobie-doobie-doo. Right. Yeah, that should be like a stream event. Okay, yeah, so we got a stream event. So now we can switch on the thing. And if we get next, then it's a string. And then we do this. If it's completed, yeah, then we'll break. All right. Otherwise, it's just gonna try and call next like in an infinite loop. I guess. It's just like the streaming thing. I'm not sure if, I mean, it feels like it feels a little bit wrong. Because it's like, doesn't do anything. But I'm not sure if it's possible to tell it to, well, I know it's possible to tell it to go to sleep, but you would want to wait until you actually get, like, you would want to wake up in some way, but I'm not sure, you know, if there's a way to do that from another process or something like that, or when standard in gets stuff happening. I mean, maybe you could spawn like a thread that will like check, or you don't even need to spawn a thread. You could just go to sleep. Like, if you don't receive in X amount of time, you go to sleep. I don't even know if this is, if it's even, you know, a problem. It's just that it feels like it could take up a whole bunch of computer time, since we're stuck in an infinite loop, you know. Okay, anyway, right, we are out of errors, so, or zig errors, zig compiler errors. So let's try this, and of course we get segfault the first thing we do. Wait, did we get segfault there? No, we didn't. It just looks weird. Okay, yeah. Segfault at address 0x1. Interesting. Yeah, of course that does not exist. So we're executing and we're running. We deinitialize value as stream. Okay, let's see if we use this correctly here. So this would, like, from value, this would, oh, so this does work or what? It's kind of weird. The LSP doesn't allow me to check this, but it seems like this works. You could also do this, so move this over here, and now this is still the correct thing, but now we get LSP stuff here. Okay, from value it will transform this into stream T, and during this process we want this thing. If we have a string, we return this. So this is what we actually get here, is we're initializing this thing here. And what could be the issue? Right, because this should be a pointer. Oh, it's not a pointer. Whoops. 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 And whoops. Okay, there we go. Cool. So we're basically transforming any value, well, any value that we have, you know, support for in the transformer to a stream of string. We could potentially add any kind of type in here to transform into whatever it's stream of string. And let's try the array now. So we go to, what was it? Test? No. I mean, we are kind of doing hello world. Let's do hello world 2. So let's make an array. Hello world. I'm not sure if this is gonna parse correctly because it's like multi-line. No. Well, let's try doing that. Okay. So we did get hello world. However, we also got a bunch of leaks or something. Yeah. Is it like the inner buffer doesn't get? Let's check this in the map stream. It might be that the inner buffer does not get deinitialized properly. So when we deinitialize you, we deinitialize the ref of this thing, but we don't initialize the ref of the source here. So we should do that as well. So self source initialize. No, it's just self. Wait, no, that doesn't work. No, it's parent. And then parent source initialize. There we go. Okay, we still got some issues, but it seems to work better anyway. But we get general protection exception. All right. Okay, so let's see. Yeah, the source to initialize doesn't work then. Was it already? No, that wasn't already initialized. Oh. I see what's going on. So, well, I think I see what's going on anyway. Yeah, I think I see what's going on. So basically, we need to ref the source when we get it. So, in order to keep a ref around. So basically, when we initialize this source, we need to ref it. And the question is, where do we do that? I mean, I should always have the kind of convention that when you pass in a ref, we ref it here, because we don't know if the parent or the caller here refed it or not. Although this is not really a ref though. Which, okay, that's also an issue. Wait, how do we ref streams now? Oh my god. Yeah, how do we ref streams and where do we keep them? And oh my god. That's the thing now, is like, okay, no, actually the refs are basically, they are not really so the refs are you could just create basically what's happening is the ref counter just gets added up. So if you release a ref, it just decreases the counter really. So actually we could just create a ref and then don't care about the result of that value like that. You could, so basically here is like we could go in and somehow if we could ref it, so let's say now we need a ref, we actually need a ref vtable function. So let's create a ref here. So this would be like or get ref. Let's call it get ref. It's get ref kind of sounds like, let's call it new ref. New ref, we'll make a new reference. Because get ref kind of sounds like you're just getting the one that's like in there. Get parent, let's do get ref will get us the, oh shit, but this is, no, new ref, yes, new ref, but we don't actually we don't return anything. We could get an RC error, but we don't return. So this would get the parent and then call ref here, but then we throw away the result because we don't need to keep it around. Although we would like to call release, like the initialize on it. But we are no, we're not actually. Oh man. The problem is the return type. Like if we could return the actual type, it would be good, but we can't because the interface doesn't allow, you know, to change the type here based on the implementation. This is supposed to be a function that you could call on the interface to create a new ref, which we can. The problem is though that how do we release a ref of the implementation, because that's basically what we need to do at this point. We can deinitialize the source, but how do we create a new... Wait. No, okay, so we don't need to... Okay, wait. No, we create a new ref, we deinitialize the source. Yes, okay, this should work. I'm just kidding. Did we already do all this? Buffered, single, mapped. No? Alright, because it's... Okay, that one. Okay, now we need a new ref. Okay, so wait. Right. Yeah, we need this as well. New ref. Okay. Now I need to go to the vtable, add new ref. Okay. And then we need like new ref here. RC error. And we will call vtable new ref self. Return because of the error. Now, right. Okay, now we will call new ref on the source. Okay. Oh. Okay. And then we should have another ref. So yeah, we don't really need to do anything with it. We just need to create it so that we can call the initialize multiple times now. However, there is actually an interesting issue here now. Because when the ref gets released, I think it's like we call release and then we set RC to null because this ref has been like, you know, it has been consumed basically. But in this case, we actually don't want that to happen. So it's like, well, I guess we can kind of work around it actually. We could call deinitialize and then like reset RC. back to what it was. Because setting it to null is basically like a safety thing, so you don't call release on the same ref multiple times. But I guess we have like a pretty good debugging tools to actually catch that issue. So I think maybe this doesn't really do a lot for us right now. Or, well, we could, okay, so what we also could do actually, instead of messing with this, because this could have other repercussions, we could, like, when we deinitialize the things, instead of calling ref deinitialize, we will call, because we should have something here, we will call rc deinitialize, or not deinitialize, release. Yeah, which will then that will then we don't need to, we basically don't need this ref kept around. We just call release there, which means we can call release, we can call this function multiple times, which is basically what's happening, because I don't want to have to pass around a bunch of RC's refs to streams, because that's what we have to do otherwise. That's going to be super annoying. But I get, yeah, it could be the correct thing to do, but let's do it. Let's just do it like this. And this is not marked public, of course. Let's just make it public, whatever. There we go. You're not supposed to call it like this, so that's why I made it like non-public or whatever. There we go. Hello, Polaris. Thank you. Have a nice day yourself. What are you up to? Boom. Still doesn't work, of course. Are we call? Yes, we do call new ref. It's not leaking. It's general protection again on the same thing. Source v table initialize. What is happening? If this goes in, we're creating a new ref, returning it, right? This in itself will increase ref by 1 and so on. So also we keep track of the ID to make sure like which refs are getting released and all that. I mean, we could make a list of refs. I guess we could have a list of refs, and then we pop them off when we call the initialize or something. Or, you know, the other option is to have these in refs instead. That would change. I would have to change everything. But also, how would that work with the interface? Well, okay. Let's do no. There. Let's enable this and executor. Okay. Let's see what's going on here. So we have this mapped value that gets created. Right. Oh, what? And then it's like deinitialized. Yeah, it's right at the end, of course. So basically, we're evaluating this value and we get an array, and then we create this some kind of string here for some reason. That's the string ref. Yeah. Okay, so basically, let's see. So we get this array of values initialized as a ref. Now, wait, yes. Yeah, that's the array, right? That's created from the literal thing. All right, and then we have this buffered stream of values also created here. And then we increase the refs there. And then you get initialized, which should initialize the one of the buffered stream refs. But that does not seem to work. Like, we haven't even deinitialized the original buffered stream here. So that's weird. Like this self here, stream 302. Is stream of T, right? This is stream of T. We are just trying to call the initialize on vtable. Which should be set, of course, otherwise there's gonna be a compiler error. So it has to be this that fails. Yeah. And you can see here it's like, okay, well the first one, yeah, this is the stream, like the mapped stream, so that goes into the initialize. Call the initialize on source, which in turn will try to call that. And apparently there it fails for some reason. It might have actually happened after the initialize. No, wait. No, this call goes into the thing, yeah. The RC, where is that? Okay, we don't actually see that. No, we just initialize here. Oh, what the hell? We're releasing ourselves, which means that our own pointer gets destroyed, and I think even we're like setting it to I don't know. We're yeah, okay. Hang on. What if we did this? This is probably correct. No? Well, okay, we get leaked memory now. Okay, that's a little bit better. Okay, I think I know what's going on. I think it's the values in the array, maybe? Okay, what gets leaked? You get leaked. That is the stream of values. Okay. What? You don't even get one release? What? Oh yeah, it's not logged because I'm doing the whole I'm doing the weird thing. Right, it's released. Yeah, okay. I'll do this weird thing actually. Instead of calling release here, I'll actually do another weird thing. I will go to the ref And I'll add a weird function here instead. So this would be kind of, this would be like refresh. Which would basically check if the RC, I guess it tries to check if the RC has refs left, and then kind of restores this ref to that. We could also have a different deinitialize function, maybe. Yeah, I guess that also works. We could have like refresh ref. So this is like if options refresh ref and refs is more than 0. So then we don't want to set it to null. I guess we could also say like if refs is 0 or refresh, or we don't have refresh, we will do that. Right? If it's 0, we set it to null. Otherwise, we check if we want to refresh it. We don't set it. Yeah. So now, instead of doing all this, we will do the init as usual, but we will set refresh to true. So this will be kind of a special kind of refresh. The only thing that's kind of weird about this is that what could happen is that if you have two refs, let's say, and you deinitialize both, and one of them is like refresh ref true, if you call deinitialize again, that would now be like a seg fault there. You would go into invalid memory because it thinks that RC still exists, which it doesn't actually exist. So because it has destroyed itself. So that's what could happen with that. But I don't think it's going to be an issue here. It's just if we call like the initialize on this more than you need to, which we shouldn't. So let's just do that. Okay. It would have been solved if we could get a ref to the original thing, but we can't really do that. Still get issues? Okay, what's the issue now? General protection again? Okay, so we are actually calling it more than we should maybe then. Okay, so we have a bunch of these. This is the stream. We have two refs on the stream. It gets released here. And the mapped stream gets released. And then I think we're trying to call that, and here it gets like we can't unwrap it. Oh wait, so if we need to check if we have RC. No, we should have RC though. Okay, we'll do this. We'll return a bool here. This will return true if this deinitialized itself. So if we did this, we return true, otherwise return false. This one is true as well. And right, so what we'll do is we'll check if this was true. Then we do that. And then here we have to check again. If we have it, well, we could just do this. I mean, here we could just return actually. So then we can basically assume that if we get down here, we should have it. Well, okay, now we get leaks again. We're going back and forth here. Okay, so it actually puts this out, but we get leaks. Okay, so what do we get leaks? Maybe we already put it out before, I don't know. Okay, so this is still the buffered stream. So we have two refs. One gets released here, and the other one leaks. So this one gets released, presumably from the mapped stream, yeah. Okay, so I guess we have to like release the what the hell? The original when we create it in the transformer maybe. Because here we're like we're creating a new one here, and then we're doing map, which will kind of create its own ref. So I think that we have to release it here actually. And there we go. Cool. So let's go memrc false. Okay. Hello world 2. Cool. So we can turn, now we can turn them into a stream of strings. Also, man, time really flies. Welcome back, Penguin. Sorry, I forgot to say that. Okay. Well, I think that's gonna be it for today. So really, what can we say we did here? I mean, what we did was basically now expressions, like any kind of expressions are turned into a stream of strings and then output to the context that we're in. So basically now also, like if we put this into an, well, okay, it can't understand what type this is, but if we put that, it's actually like an array of strings. Oh, okay, it doesn't understand. Anyway, it's an array of strings. So now if we run this, we get Oh, we don't have types parsing for arrays. There we go. Yeah, if we run this now, nothing is output because the context has changed. So this still, you know, it's an array, but it's put into this variable here. Now, if I were just to say this variable now, we should see it being output. If I say a variable a whole bunch of times, we should see it being printed a whole bunch of times. So yeah, any expression out here that can be turned into a stream of strings is going to be doing that. So we can kind of change yeah, we can work with this and try to fit everything into this pattern maybe now, but we also need to support things like, you know, if there's an error, we could also play with like a delay. We could see how this would work with a delay, because potentially you could have, let's say, well, actually, what happens if we have a block and then we have hello? No, this would just not do anything, I don't think. No. Do we get an AST? Yes. Yeah, I don't think this would do anything. If we echo hello, it will do something though. Or not. Well, we can echo. Oh yeah, I think, okay, this will show it. However, if I know what's going on, because this is actually a process handle, but so if we say standard out, now it should do that. No? Okay. That doesn't work. I thought that was a process handle. Maybe it wasn't. No? Okay. Well, let's say we make a function called hello, and we say echo hello, and now we call hello. We should see hello. Yes. And now we store this in a variable. We don't see anything. Oh, unsupported type expression. Oh, I see. Now it requires one there. Okay, unsupported type expression. What? I see. Well, what if we did this? No. Okay, what if we did this? No. I wonder where this error comes from. Anyway, the point is that anything you put in here is supposed to be able to like be turned into like a stream of strings, basically. So yeah, that's basically what we're working with. And the stream of strings can then be like, if we coerce, let's say we pipe something into cat, let's say, so that this should still work. It does still work. If I do like server log, actually I need to wrap these in quotes. Server log, that should work still as well. Yeah, you can see it, like it gets the hello first and then the server log here. So this output, the output of this is piped into this, right? But it should still work for this kind of expression. Like if you have a string, anything that's gonna be put into standard in pipe is gonna be able to be coerced into a stream of strings and then piped into whatever we have here. So this would be able to be piped into there because it's just a string this, because it would check, okay, what kind of expression do we have here? Okay, so we have like a function that takes a stream of strings as standard in. Okay, so now let's check if we can convert this into a stream of strings, and which we can. We have one string, so that should be like a single stream with this string in it, and then pass it in here, right? And the same should be for the array. We should be able to put this array and then pipe it into cat as well. Right now it doesn't work because yeah, we don't have that. But okay, it should be very easy actually. Wait, should we just try and do that right now actually? Okay, so where is this error at? Primitive value in pipelines. Okay. Primitive value, yeah. So we could try to do this here now. We get the value and we do run value as stream, and yeah, let's have the evaluator scopes. I'm not sure what we need actually. We might really not need anything, maybe, actually, because we already have the value. So yeah, let's just try and do this. Well, we need the value, of course. So I'm just gonna copy this for now. Run value as stream. And we don't have any of this. What we have is the value, which is a value. Now, is it pointer or what is it? Yes, pointer const value. There we go. And we get like this stage execution. Oops. And we do some stuff that we do for all of these. So yeah, here, like, we got a result. We don't really, well, we could make that. So let's do this. Let's try to get a stream out. So we need to import stream from stream. And this would be a stream of strings, because that's the only thing we support right now for pipelines. And it's gonna be from value. Okay, so we do need allocator. Do we have allocator on here? Yes. Where did you go? Right, allocator, and we have the value. Right, so that's gonna give us the stream. Now, or not, it could also fail. If it fails, then there's some kind of invalid, well, this fails as an RC value, I guess. But we would get a stream. We would get like a failed stream if the source was not working, and it would fail later when we try to run it. So I guess now we have to do like the streaming thing. So really, we could. All right, let's make an allocating writer. Writer allocating, or can you make no init? So we'll make the allocating writer and then we will do while stream next, or actually you know what, I think I want to change the streaming thing to be like we get like while next, it should return null when it's done, because then you can just say while stream next and you don't have to like check for completed. However, inside you could check like, okay, did we get a value or not? So it's kind of like a two-layered optional almost. But we'll do like try. Let's do like while true. And we'll switch on try stream next. No, not new ref, next. And then we'll switch. Well, we're switching on it right now. We can actually wrap this like this. Alright. So then we need to check if it's completed. We will break. If we get next, we get a string that we can then append into this writer. So this would be like write all string. All right. Oh, this, well, okay, let's do like value stream or something. We already have a function called stream, so that's why it's complaining there. Okay, so at the end of this, we should have filled up the writer with a bunch of standard outs, but we could have also gotten some kind of error here. So I think what we could do is we could say if we got an error, we will, well, this is like an optional error. Well, this is like a stream error. Well, it's a stream error, there we go. And you are null from the start, but if we catch you, well, let's call you stream error. We will set stream error to error, and then can you break from here? I guess you should be able to, since we're like in a while loop. Right, we're in the switch here. Okay, so if there's an error during the next one, we break and set the error here. Otherwise, we check if completed or if we have a next. Okay. So if we got an error now down here, we will check if we got a stream error. We do that. And then otherwise, we will success and the value. Wait. Oh. Okay, we could have just returned the value, I guess. What the hell? Wait. No, that's not correct. This I think this value is just gonna get thrown away actually. Where's the result used? I think this value, we need to like deinitialize it. The standard out is No, wait, this is all wrong. No. Okay, so in the context of piping, yeah, I think we need to store this in the standard out in here. Where does this standard out come from actually? So the function standard out, that's the run function result, right? So that's, oh, I see, that's stored in there. Okay. Well, I guess we could just create this result right here. No, so okay, so I was just stupid there. Yeah, that's what happened. All right, let's do that, and then the value. So this would be like empty, basically, and you would be the not the value. You would be like alloc writer written, except we want to dupe, perhaps. We could even do like to owned. Possibly. And then you are started at, and you are finished at. You should exist, yes, but then you could be an error, so let's do that. Okay, there we go. We've successfully did that. Now we just need to import that. Are you public? No. There we go. Finish that's not okay. Right. It's gonna be here. There we go. Args index. Oh, okay. So we need args, right? Args. There we go. Because yeah, it basically is used for the which stage in the pipeline is this? I think that's the thing. Yeah. Okay. Switched on type optional stream event. Oh. Okay. Yeah. Okay, I guess we'll do like or else continue. Where are you an error now? Oh, this one. Okay, fine. Okay. Should this work now though? Well, we got some leaks. Okay, let's look at what we're actually doing here. So, all right, so we're doing, we have an array, we have a function. We don't really care about the function, so let's get rid of that. We're piping an array into cat. So we should be seeing like this string and then the server log. So let's check what it did here. We got a bunch of leaks. That's fine. And there you go. We can pipe and potentially anything basically now into things that are like yeah, could course into a stream of strings can now be passed into there. Cool. Hello, piano coder. All right, thank you. Yeah, okay, so then we have a bunch of leaks, and yeah, we're not really taking care of the stream, so we need to do that. Initialize, there we go. I think that should maybe do it. We could have other leaks as well. No, that was the leak. Awesome. Wow, okay. So yeah, now we can pipe anything here. Anything that can be coerced into a stream of strings. And right now we only have support for strings and arrays, but we can easily add more things. Except it didn't work there. God damn it. What? Okay. Why is that not working? It feels like this should be the easiest. What the hell? Oh wait, I know what's going on. It's because we don't support. Okay, we have to store this basically in a variable first, because we don't support parsing a pipeline with like bare expressions. You have to have like an identifier. Okay. Also, this fails here. Type checker. Well, I will disable the type checker right now because it's not fully implemented. Wait, skip type checker. Skip type check. There we go. Now it works. Yeah. So, there we go. How much is finished? I haven't really thought about that, like in percentages. Like I know that I want to get. Okay, so I should draw a line somewhere. You know what I should do? I should probably take one of my like bash scripts that I have, and basically once I've gotten all of the features that you could make. That I can rewrite the bash script in Runic, then I would consider myself like good enough to be able to use. So that would be cool. But right now I can't really say. But what I want to have though is gonna be background processes. It's gonna be pretty cool to have. I don't think I'm not really using that much though, but basically, yeah, background processes would be cool to have, but I think that's gonna be like a nice to have more than actually needed. But really, like functions that, yeah, I'm gonna have to make functions work as like producers of streams now, and treat executables. I want to have like streaming standard in. That we don't have that now. Streaming standard in doesn't work, and streaming standard out works, but it only works if you only have one like one thing in the pipeline. Like let's say you have this tail server log. Like this works. This is streaming the thing out, but it doesn't really you can't pipe it into something and then expect it to stream it. You know, you can't really stream it into something else. We don't have redirections to files basically. So I want to have redirections to files, streaming standard in, streaming between in a pipeline, and possibly streaming to like a variable should be easy to have once we have like redirections and stuff. Maybe like optional types. Yeah, there's a bunch of stuff. So so you could say maybe I don't know. I would say maybe like 30%, let's say. If you wanna say some number there. But we would be able to track the percentage pretty closely if I make like a finish goal bash script that we should be able to like replace basically. So I should really do that. We should have like a bash script that like, you know, oops, why is that so can you set it to 50%? No, win width. How can I do? Okay, I just quit out the whole thing. Let's do like what would this be called? MVP.sh. And then we'll have an MVP runic. So basically, you know, echo calling a thing. Sure, we can do that. Okay. Why is the thing not working? There we go. So like bash MVP. I guess we could set up like yeah, hello world and then runic MVP. So basically the result of these two should be the same, and I'm not sure exactly how we're gonna be able to check it, but you know, I could make a runic script to check it, maybe. Check MVP. All right, this is probably like the first actual runic program that we're gonna have, like, you know. So basically, you can run bash. Yeah, the special syntax is not gonna be there later. That's just because I was thinking first, like, hey, you could have like bash blocks embedded in runic, but I don't think I'm gonna have that. So that's not gonna happen. But this will be like MVP bash. We can store the result in bash result, and then the runic result in runic MVP runic, and then we'll check if bash result is equal to runic result. Then they are the same. Otherwise, they are not the same. All right. And then we can run check MVP, and nothing happens. Okay. Wait. Why is that happening? Yeah, okay, there might be some parsing issues, something. Yeah, it's not able to parse here for some reason. I'm not sure why, actually. Is it the bash thing? Unexpected token. Okay, you know what? I'm gonna remove the bash thing. I think we have like keyword bash. Yeah, it's so stupid. Yeah, remove please. Bash, please remove this. Okay, thank you. No, wait, it's still not working. Why? Oh, I see. Yeah, these need to be quoted. There we go. There we go. Oh, we leak memory. Okay. Well, we can remove this now. And that. Okay, interesting. We're leaking memory. At the top of all. Holy crap! That's a lot of. No, here we go. Unsupported binary expression. Okay. What? Oh, I see. So we don't have equals for strings. We should at least have that right now, I feel. Unsupported binary. I should have fuzzy finding here. I don't know why it's not there. Okay, so we have a bunch of these equal. So if they are numeric, we have it. Let's also have if they are. Wait, what's happening here? if it's a string, and if right is a string, then we will return a boolean that checks. Actually, we need like left string get, right string get equal left and right. Okay. Still got a whole bunch of leaked memory. Still get unsupported. Huh. Or is this like an assignment? No. What? Oh wait, they are not strings. They are not strings, right? They are like process outputs, right? So we have to check standard out. There we go. Okay, a little bit tricky. I guess, I mean, we could also do this. Classic bash. This is what I wanted to not have in this language, but classic bash, like, you know, safety checks here. You create these things and they magically make it work, except you still get leaks for some reason. But yeah, they are the same. I just need to fix the leaks. Hey, what is leaking here? The literals. Execute statement. This value. Render string literal. From where? Evaluate. Okay, so we have a bunch of string literals that are apparently leaked. Wait, should we... Hang on. The binary... Wait, we should deinitialize the things. Yes. Okay, okay. We have to deinitialize them. These ones, yeah. Wait, no. Okay, yeah. There we go. Also, we should deinitialize them here straight away, actually. We should just deinitialize them. Because you saw what happened, like... Everything should get deinitialized. I guess if it's like... Yeah. this should all be initial. Actually, can't we just initialize the whole binary expression? There we go. What? Okay. Oh, the expression. Wait, the expression does not. Oh, okay. No. The expression does not need to be initialized, but the values, when we evaluate them, we need to initialize them. Yeah. I know this looks horrible here, but I have to live with this for now. Okay, cool. So now when we get this error, we won't get a bunch of leaks. Yeah, it did work, but it's, I want to, so wait, expected 0, found 1. Oh, god damn it. Okay. Okay. Now, oh, sorry. God damn it. Come on. Equals that. There we go. All right. Cool. Let's just assume everything went to plan and we'll go with it. There we go. And if we go and let's say we have like an unsupported here. Oops. We have this unsupported expression. File not found. What? Oh. Okay, unsupported binary expression. Good. Now we don't get a whole bunch of leaks just because of that. Okay. Cool. Hey! But this is not the MVP, so... And also, we should, like, this check is very naive. It just checks if the strings produced are the same. But I guess that's a good start, I guess. what else? Like I would like to have like, you know, file redirection. We don't have that. Actually, the equivalent of this would be this. So actually, but this kind of shows that, hey, you can actually call echo. And whereas this we don't. But we could do echo, and then we could do here printf, let's say, whoops, did I see? Printf, hello world, hello from printf. And then the equivalent here, since we already know we can call commands, is gonna be hello from printf, except this is not printf, this is like without new line. Hello without new line, because this will automatically be the same thing. So if you check, hey, it works. Awesome. Now you don't really see the execution here, so it's kind of lame, but yeah, so let's do like MVP runic, and there we go. So yeah, I can just I can just fill this out for whatever we want to have. So basically, hello cat into cat. And now, okay, so if they're not the same, we should maybe produce like a diff. Actually, you know what? We have the results. If they are not the same, we will... No, because we don't have... God damn it. Oh, but we can use bash. Haha. Wait. Can you, how do you inline a bash command? Is it C or? Yeah. So you could do like C, and then I could cheat here, like, right? We can cheat. So let's do let's do like bash. So bash results, I'm gonna put that in quotes. It's gonna be a bit iffy here, but let's put this in MVP bash dot log or something, I don't know. Okay, and then we'll do MVP or runic results into runic, no, MVP runic log. Okay, first let's see if this works here. Oh. Okay, let's see, what are we actually trying to say to bash here? Okay, I guess or maybe we could use here docs, maybe. How is it like this? For echo EUF new line this EUF perhaps. How did it work? Or was it two? Here doc at line 1 delivered about what an EUF. Okay, what does this produce? Okay, I guess we don't need... Well... So how do you put this in to the file? This is the thing with Bash. You always have to look up these things. That's why I'm building this new language. Here doc redirect to file. Like every little thing you have to do in a separate way. Cat? Okay, so you have to put it first. I see. Okay, so you have to put it like this thing you have to put up here. Okay, so let's do here mvp dash log. There we go. Let's see. Whoops. How that looks. Okay, that should maybe do it. Except we have to remove this one here. I guess we could store this in a command. Or in like, yeah, bash. So this is like bash store bash result command. And then we just copy this in here. No. Type checker, no. Skip type check. Okay. So what do we have now? Do we have a bash log or mvp bash log? Okay, we do, but it's empty. Why is it empty? Okay, you know what? Forget it. Let's just try to do this. No, still empty. Oh wait, no, we should use cat. Maybe that's the issue. Cat. Okay, there we go. Okay, let's check if we can do this now. Oops. Okay, there we go. Now we have that. Okay. So then we want to do the other one. And we don't have functions right now, so I can't like change the thing. So let's do like runic, search for bash, replace with runic. And store runic results command. All right, let's see now. They're not the same, so we have bash and runic. Okay, next up is diffing these. I don't know if you, well, maybe you could like, because we have, there's like a diff thing, but I have no idea how it works. I guess you could just do like diff mvb. I basically never use this. I use git diff if you wanna diff things with git. No. Well, that just gives you like the thing. Can you change like the format or something? Or CS? What the hell is that? Okay, I guess that'll have to do. So then when we have this, we do like diff c. Okay, yeah, let's store this in file names. So bash results file is mvp bash log, and then we have runic is in runic, and then here we could change to bash result file. See, now we're actually using the language. This is like the first time I'm actually doing something in the language like this. It feels kind of strange. Okay, so then we'll diff bash file and the runic file. And we'll run the thing. Where is it? There we go. Okay, there we go. They are not the same. And here's the diff. Cool. Yeah, and I guess afterwards we can just remove the files. So let's remove. And I could use, you know, proper whatever, temporary whatever, but yeah, and now we shouldn't. They are not there anymore. Cool. Yeah. And then we're like, okay, well, can we do this? No, we can't. Or we can, except the output is a little bit different. Hello cat is actually on a new line. Yeah, okay, so or wait, what is the output actually? Hello cat, echo hello cat into cat. Okay, and then we get hello cat again. I think what's happening is that this might... It shouldn't forward it to the outer context. Okay, well, anyway, I would have to go now. But yeah, very, very cool. This is gonna be it for this time, so we'll continue next up. I will try to fill this out and get all the features that I want, so we can like compare here. And but yeah, that's gonna be it for this time. So thank you very much for joining, and I will catch you